Thanks for joining us and welcome. This is our workshop on interoperability and analytics of EHR data with special attention to features of SNOMED CT. I'll acknowledge my colleagues as they participate, since everybody is not here yet. But a few words of intro. Okay, right tab or right. What do I do to
right
it?
Arrow. The right arrow on the. Oh.
We're doing a little technology transfer here.
Oh, it's still on Zoom. So yeah, now it's got the right focus. So you should just be able to press the.
Where do you have to? What did you have to do?
Just the right arrow and the back arrow.
That's what I did the first time.
Yeah, it was on Zoom, the app,
Oh,
instead
okay.
of on the.
Okay.
Yeah.
But I do want to acknowledge some individuals outside this room, outside this presentation, that were very important to getting this material together. Olivier Bodenreider will be presenting some material from NLM about interop of medications. And Robert Wynn is his research programmer at Lister Hill, who did a lot of the work to develop the OWL. Back home at Nebraska, Jay Pedersen is a research software engineer for the Nebraska Public Health Lab. And he prepared the browser that we're going to show you with the clinical LOINC, with the LOINC integration. B2I staff, you may or may not know that at Nebraska, we use SNOWOWL for our authoring environment. And the B2I staff have helped us innumerable times in the past several weeks. Rory Davison, you probably heard of him. He is the Chief Information Officer for SNOMED International, and he helped with preparation of the browsers and other technical details. You may have heard of the Drug Model Working Group, and Julie James and Tony Morrison were the leads on that, but they asked me to emphasize that there were many in the SNOMED community that have done a lot of work on developing an international model for interoperation of medication that we're going to be talking about here today. And finally, Scott Campbell chairs the Pathology and Laboratory Medicine Resource Group. And just recently, we have been successful in getting pathology observables promoted to SNOMED International. And Scott is going to show you a little bit about that today, but it's the result of the work of many individuals. Welcome to those who are on the Zoom call, and I hope you're hearing us okay. In the handout material, which is posted on the web, and if you're having trouble here in the room, getting those materials, I do have them on a flash drive as well that you're welcome to come up and get during the break. And on that, we have some reference material for today's presentations. One is the guide from IHTSDO on how to use expression control language or constraint language. And we're going to be using that for some of the exercises today. The SNOMED editorial guide is the best resource for looking at the and understanding the SNOMED concept model. And I've included a PDF of that to make it a little bit easier to reference where content is. So the page numbers that we talk about refer to that PDF. There's a technical paper on the international medicinal model. I've got a copy of the PCORNet common data model because I will be talking about them. And an allergy implementation guide from Bruce Goldberg that has been the result of long work in creating interoperation, support for interoperation with allergies. And finally, we're going to be doing some ECL exercises as a part of the workshop. And those of you who actually want to work through some of them yourselves or miss some of the details in how to deploy them, I've got a Word document with all of the ECL queries from all of our presenters organized, so that you can go back and work on those at your leisure, or you can open a copy today and do some of that work yourself. So I'm going to talk a little bit about interoperation and what it's all about. And then we're going to explore three major use case areas. The first is in SNOMED CT clinical findings and how the concept model supports interoperation of problem lists. Second will be SNOMED substances and medicinal products and interoperation of medication data. And then finally, Daniel Karlsson is going to lead the group on discussion of observable entities, some brand new enhancements to the concept model in SNOMED that have to do with interoperation of laboratory and pathology tests. And you may or may not have heard or been over at the in the Judas 1 just in the last hour, but Loink and SNOMED have announced a renewed cooperative agreement with a plan for publication of a SNOMED extension for Loink, which will contribute, which is actually at the heart of some of what we're going to demonstrate in that last session. Now, the ministers this morning, talked about what's involved in getting a worldwide electronic health record. At the basis of that, if we're ever going to achieve the vision of being able to actually share electronic health record data, is the concept of semantic interoperability. And it means that computer systems have to be able to not only exchange data, so pass codes back and forth, but they also have to be able to exchange the meaning of the data. So computable knowledge, if you will, that basically defines the conceptual basis for what is being transmitted and shared. So this is a theme that we're going to come back to a number of times. And while the ministers talked about the fact that they anticipate that there will be a top-level ontology with the Global Digital Health Partnership at its basis, and employing tools such as the International Patient Summary, they didn't get into the technical details of what it means to us, the data scientists and the computer scientists. How is that actually going to happen? And I would suggest to you that this model for interoperation is what we work with at Nebraska as guiding principles from the standpoint of, in constructing our computer systems and employing our clinical vocabularies and the like, this is our model for semantic interoperation, in which case you've got a top-level ontology, which is like the major classes of things that you're storing or remembering with your computer system, okay? And that's where that global data partnership comes in terms of identifying the major types of information, such as medication orders, problem lists, lab test results, and things like that. Those are the top-level classes. If it's going to be semantically interoperable, though, those are never specific enough to transfer full meaning of a particular record. And so bound to that top-level ontology is a set of vocabulary models. Some people call them domain ontologies, of which SNOMED is an example, okay? Which basically carry the meaning details about all those individual elements that go into what is the top level class. For a problem list, the diagnosis or the finding is a major feature of what has to be in that record, okay? And the binding of the SNOMED CT clinical findings to the top level model in the record structure that's supported by the information model, that's how you start packaging meaning in a way which a computer can actually process and resolve. Then at the level below that, you've got a data representation model, which is all about your data types, understanding what's a number and what's some sort of a reference to an external code system, et cetera. And generally, a computer system has got to be supported by an interface terminology, but that does not have to do so much with interoperation, because that's just making it easier for the user to create a record, to use the system, okay? Within the system itself, the binding of these three top-level elements, the top-level ontology, the domain ontology or terminologies, and the data representation model in a uniform manner that is shared between the computer systems. That's how meaning gets encoded into data in the electronic health record. And as I mentioned, in the Global Digital Health Partnership, the medication summary, the immunization records, the diagnostic results, those are the top level classes, okay? And then serving that, if you will, is a binding to vocabulary models, which if you look at the HL7 specs, basically occurs, for example, in the FHIR implementation guide in terms of what vocabulary systems are appropriate for this part of the record in this particular record. So FHIR, and in some parts of the world, the CCDA, is still in use. It was also a V3 HL7 spec for how to bind the terminology model to the top level model. Rob Howsam tells me that that is slowly going out of fashion, if you will, and that FHIR is the wave of the future in this particular case. So, to be very concrete, FHIR gives us roadmap, if you will, of where we use SNOMED CT in these records that we transmit to Australia or other colleagues. So, needless to say, we're going to focus on SNOMED's utility as that domain ontology, as that vocabulary, okay, and what you can do with it. And I'll tell you that today you can do quite a lot, but that wasn't always true. SNOMED was first started as SNOMED 3, which basically was a 5-character digital hierarchy that was the only way that relationships were implied between concepts. So I mean, it was hierarchical, but it didn't have a lot of definition beyond that. With the release of SNOMED, come on up, Ken, you're up next. So SNOMED RT really was a game changer, okay? The implied relationships of the hierarchy in SNOMED version 3 were replaced with explicit relationships, which became part of the defining elements of how the computer is to capture meaning. And we'll show you in several parts of SNOMED how that meaning is actually captured and how you can use it as a knowledge base in your analytics and interoperation. But SNOMED RT introduced the concept, the issue of relationships, and also they began to use a classifier, which is a very complicated logical machine which evaluates a piece of our a record in a description logic format, and basically computes what it is, what it's equivalent to, what it's not equivalent to, what it's related to, okay? So the introduction of the description logic classifier and the concept relationships feature of SNOMED RT really began to create a path towards what we would call today a true ontology, all right? SNOMED CT changed to a description logic classifier. And you may be aware that recently they've introduced OWL formalisms. So now the relationships are actually something called OWL axioms, which basically define this is equivalent to that, or this is a subtype that is a child of that, okay? And this particular clinical finding has a finding site of the lung, for example. Okay, all of those elements that used to be in relationships are now moving into OWL axioms. All of that basically to create more interoperability, because we're looking to the future when this information can actually be shared with a semantic web. There has been a lot of work over the past number of years under Jim Case's tutelage, among others, all the terminology editors of SNOMED, that basically have been working on the quality of the domains or hierarchies, if you will, in SNOMED. And so there's more and more electronic health records that are using SNOMED CT, the advances in the concept model create opportunities, which frankly, we don't think a lot of people know exist. And that's the purpose of this workshop today, to explain some of the features that you can get out of the knowledge base of SNOMED CT. Now, when I say interoperability, I want you to think of reusing, okay? That's a good definition of what it means to be interoperable. Data that's recorded in one place can be transferred to another, and they can use it for whatever purpose they want, given an understanding of what it means. And today, in the course of our workshop, we're going to be exploring three separate sort of use case scenarios: clinical decision support, where it's used in the electronic health record; clinical data research networks, where it's used to actually fuel scientific research and help to improve healthcare, and also reporting of morbidity and mortality across the world for public health and epidemiology. So how many people here have heard of the machine readable concept model? Okay, well, there's a few that it's a little bit new. The rules by which relationships, or I should say in this case, the OWL axioms, can be employed, and what values they have to choose from in order to populate the relationships, that's maintained by SNOMED in something called the machine readable concept model, which is a set of computable rules that computer systems can also share. So they understand the computer system can actually compute whether a rule is properly constructed or not. All of that was necessary because early experiments, when we first had SNOMED International, we tried cut and pasting a lot of relationships and a lot of values together. And you know, not all of it made sense, which is why the concept model exists today. It has to be logical, it has to be reproducible, and it has to be useful in terms of capturing important knowledge information about a concept. Now, in the handout material, you'll also find a copy of the editorial guide, or you can get it on the web as you see the URL here. And in the editorial guide, there's detailed sections on what the machine readable concept model are for all of the SNOMED domains. We're going to refer to it once in a while here in the workshop today. If you want to read more about the machine readable concept model and you're interested in that, I've also got documentation on that. But suffice it to say that as of 2022, a number of major domains in SNOMED have had sufficient editorial work, quality improvement, as I said, under the direction of the SNOMED editorial staff, to basically improve those domains as knowledge bases. And I would refer you to the concept model pertinent to clinical findings, substances, pharmaceutical and biological products, and observable entities. And I've got the page numbers there with reference to that PDF. It's a little bit confusing in the editorial guide because it's a fairly long document, but you look at those sections, I think it'll be easier to understand what I've been saying. And it is basically the discussion of how the concept model is applied to these areas in that top level model. Okay, that's going to be the focus of our work today. I want to mention a little bit about expression constraint language. And Dion, it's Command Tab to get to the browser, right?
That's it. And you can see Firefox and Chrome there. So you just press tab, keep pressing tab until you.
It's the Chrome. Huh?
Yep.
Okay. All right. So most of you, I think, are probably familiar with the SNOMED browser that Rory's people have prepared for as tooling for us. You know that in that browser, you can basically go and look up a particular concept. Let's try. Sorry?
No, it's just a little bit small for them to see. So if we do, is that okay?
Go a little bit further. Yeah, that's good.
That's okay?
Yep. So here we find what we get when I'm searching on chest pain. Notice that the circles on the left have the three equals lines. That's logic symbolism for equivalence. Okay, so these are fully defined concepts that you're seeing there. And then I just tap twice. Yes. All right, and chest pain is defined in SNOMED CT in the inferred version as a finding of a region of the thorax. It is also a pain of the truncal structure, and it has a finding site of thoracic structure. Okay, that is the application of the concept model to the definition of this particular concept. What many of you may not be aware of, and something that we're going to be using today, Quinoa is going to do some demonstration in this in a little bit, is this part of the browser called the expression constraint languages.
Just once.
Do what?
You can just tap it.
We're just Apple converting here. Please bear with me.
Yeah, so you just tap in there. Is that what you wanted?
I wanted to open this. Oh, I'm sorry.
You're in there. Yep.
Okay. All right. And the expression constraint queries basically supports an expression constraint language builder. Okay. And if, for example, we want to search for, let's say, all diseases. All diseases, okay, and we're interested in, let's say, lung diseases, okay, so we picked a focus concept, all right, and notice that we have defined, we want to look for any child of disease or disease itself, and let's say that we want to add a refinement, and we're going to go back to that finding site that I mentioned earlier. And let's just look for lung structures. Okay, so I've written a simple expression constraint language query. Picked a focus concept, defined what relatives of it I would accept. Okay, picked a defining attribute of finding site. Okay, and specified what I'll accept in the value set of the value set of the answers, okay? And this basically is a tool that Rory built and his crew to basically search for those concepts in SNOMED CT that fulfill those criteria, okay? When I say okay, I come back out here and you can see it's built the expression constraint query in the formalisms, okay? So you don't have to worry about the details of the formalisms at this point. And if you go ahead and execute that, down at the bottom here, and how do I scroll down?
Yeah, we should have thought of this. It's just 2 fingers.
Okay. All right. So here you see that the query tool has basically gone in, evaluated through the description logic classifier the meaning of all the concepts that are children of diseases and found those that involve diseases of the lung. This is a simple example just by way of introduction to what Quinoa is going to be doing here in a little bit. And what was it?
Command tab.
Command tab.
Yep. Just once more. Yep.
There's a overview of some of the syntax of the expression constraint language. You don't have to worry about that now. They'll all be very simple to begin with, but there is a lot of power in that tool that can be discussed at another time and place. Now, remember I said we're going to now focus on SNOMED CT and how the knowledge that is found in the relationships and the concepts of SNOMED CT can be used to support interoperation. Now, our first set of use cases is going to be about problem list and about clinical findings. Quinoa Fung is a colleague at the National Library of Medicine. Quinoa, you want to say a little bit more about yourself?
So I'm Quinoa Fung from the U.S. National Library of Medicine. So in my previous life, I was a surgeon for about 15 years. And then I see the lights and shifted to medical informatics side. So I've been working at the Library of Medicine for about 20 years now. My main area of research is medical terminologies. I do mapping between SNOMED and ICD-10 and some 11 work. So that is what I'm going to cover in this section. So I will be covering the use of SNOMED in a problem list use case. And I'll talk about the interaction between SNOMED and ICD-10, mainly ICD-10-CM. And now at the end of it, if I have time, I'll talk a little bit about ICD-11 as well. So what is problem list, right? It all can be traced back to this seminal paper by Larry Weed, 1968. He advocated the concept of a problem-oriented medical record. So basically, everything that is entered in a medical record is associated with a problem that the patient is suffering. So the problem is the centerpiece or the main index to the whole medical record. So in Weed's paper, it says that each medical record should have a complete list of all the patient's problems, including the clearly established diagnosis and all other unexplained findings, which are not clear manifestations of a specific diagnosis, such as abnormal lab test results or symptoms or physical findings. So because of the widespread acceptance of this idea of a problem-oriented medical record, the problem list has become a fixture of the paper medical record, and eventually it also becomes a very important part of the electronic health record as well.
Thank you.
So the significance of the problem list is that it is not just used in clinical care. So of course, the primary purpose of the clinical electronic medical record is the patient care, but it's often used that information stored in the problem list is also used to drive other functions. One of the most important is generation of billing codes. And then it's also used for healthcare statistics, public health reporting and research and so on. I'm just listing the common use cases here. So as we all know, informaticians, so if you want to reuse data, it is much more useful or much more reliable in your reuse if your data is primarily encoded in some kind of a control vocabulary instead of just dealing with free narrative text, right? So that is because of the secondary reuse of the problem list data that drives the encoding of problem list data in standard or even sometimes non-standard terminologies. So the problem list is very often the first place, if not the only place, in the EHR that you can find encoded clinical data. So how do you choose the terminology to encode information from the problem list, right? In the US, according to the EHR certification criteria of the Center of Medicare and Medicaid Services, CMS. So SNOMED is a required terminology to encode the problem list in the US. And some people would question, well, why SNOMED, right? Why not ICD? Because everybody knows what ICD codes are and have been in use for a long time. Why don't we choose, for example, ICD-10-CM in the US to encode things in the problem list? And in a subsequent few slides here, I would attempt to make the case that it is actually imperative that we use the suitable clinical terminology like SNOMED to encode things in problem lists based on three things: very comprehensive coverage, clinical orientation, and better data entry and retrieval. I'll go into that in more detail. So first of all, let's take a step back, okay? To understand the difference between SNOMED and ICD, you have to know some basic differences between a classification and a terminology. SNOMED is an example of terminology, and ICD is an example of classification. So generally, the use of SNOMED is more general information capture, and classifications like ICD-10, they are designed for specific purpose, like mortality statistics, population health statistics, and so on. And because of this difference in purpose and design, they have different structural characteristics. And here are the four important ones that we need to know about. First of all, in a terminology like SNOMED, it is what we call a polyhierarchy. That means one concept had kind of multiple parents. But in a classification, that is a strict hierarchy. So multiple parenting is not allowed because you will end up in double counting if you have multiple parenting. And the level of coding for terminology is not restricted to any level. You can use whatever level that is suitable for your clinical use case. In a terminology, in a classification, on the other hand, you have to encode at the lowest level. That is also a way to ensure that there's counting is accurate. And the third thing is that in a terminology, there can be overlap between concepts. It's possible that terminologies, concepts do overlap partially between each other. But in a classification, they will adopt a pigeonhole approach. That means everything is clearly demarcated. So everything has only one code. It's not possible to code otherwise. So they have very detailed coding instructions like inclusions, exclusions, and so on. And this is also called a pairwise disjoint characteristic. And the last one is exhaustiveness. So in the terminology, of course, it's nice to be exhaustive, cover everything, but it's not a requirement. But in the classification, you need to be exhaustive because you want to make sure that every patient, every condition has a code. Otherwise, you'll be in trouble. So that's why everything has to have a code, and you have to need this residual codes or catch-all codes like not elsewhere classified or others, right, to make sure that everything is covered. So I'm going to back to that, making that argument for SNOMED-CT as the problem list terminology. First of all, SNOMED is much bigger and it's better coverage. Like SNOMED has 120,000 concepts in the clinical findings hierarchy compared to ICD-9-CM and 10-CM, which are much smaller. And another problem with classification like ICD is that it is statistical. So less common or less important diseases will get lumped together in those catch-all categories. Here I have an example of congenital skin abnormalities. So in SNOMED, you have 21 codes for all these different conditions, but in ICD-9-CM and ICD-10-CM, you only have one code. That's why they've given information loss if you encode only in a classification. So not only is SNOMED bigger, but it's also extensible. Like you have mechanism of post-coordination. That means you can make up new meanings by a disciplined way of combining different concepts together. But in ICD, there's no standard way of extension. Countries can have their national extensions, but then the sharing of meaning is not achieved because if you share, if you mix different extensions together, you cannot make sure that they mean same or different things. So another advantage of SNOMED is that it's clinical oriented because all the descriptions they come from clinical terms that are used in clinical discourse. For example, partial seizure is a term in SNOMED CT, but the same equivalent code in ICD-10-CM is localization related focal partial symptomatic epilepsy or epileptic syndrome with simple partial seizures, not intractable without status epilepticus. This is because like the description in an ICD code is known as a rubric, is that it has to state out all the conditions under which this code is applicable. So it has to state clearly when this code is used. So that's why you have the additional qualifiers. But the qualifiers are often difficult to understand. And if you need to pick between different codes, it's often confusing. Another characteristic of ICD is that there are some areas of content in which it's not totally oriented to the care of the individual patient. So one area is, for example, the external causes of injury. For example, in this code, which is a code for external cause of injury, it said that it's got very detailed description of the mode of the accident, like it's outside of a free-wheeled motor vehicle, collision with pedestrian or animal, and so on. So this is not to say that ICD is bad, right? Because they're designed, created for different purposes. ICD is originally created by WHO, and the emphasis is very much like in a public health perspective. So that is a very core function of ICD. So in order to capture all the necessary details of these things and lead to maybe actionable things that can prevent accidents, you need that level of detail in ICD. But that level of detail arguably is not needed in the care of an individual patient. So that's why SNOMED would not have that kind of detail that is not directly clinically relevant. So a third advantage of SNOMED over ICD is that the mode of data entry and retrieval is much easier, or we can do much smarter things in SNOMED compared to ICD. So as I mentioned before, ICD has codes like NOS or NEC, which are more classification-oriented codes, and these codes can be confusing for clinical users to pick. On the SNOMED side, you don't need the NEC or the NOS codes, so it's much easier for the clinical users to use. So next is the big thing, is most related to what Jim has mentioned before. It's about the use of the logical underpinnings of SNOMED to help in data retrieval. So as I mentioned before, SNOMED is polyhierarchical and also has a logical definition. So this is an example of strict versus polyhierarchy. So a disease called hepatorenal syndrome, it affects both the kidney and the liver. So in SNOMED, it's both a descendant of disease of liver and kidney disease, right? So it's one concept has multiple parents. On the ICD side, it is, I would say, almost arbitrarily, classified under diseases of the digestive system. So the kidney side is missed. So because of that, polyhierarchy versus strict hierarchy, in ICD-10, it's sometimes difficult to find all the codes that you need. For example, if you want to retrieve all the codes in ICD that is related to hypertension, so you would be tempted to say, okay, maybe I can use this block of codes, hypertensive disease, I10 to I16, right? But then you've been missing some codes that are placed elsewhere in ICD-10-CM. For example, if the patient is pregnant, then there's a block of codes under the O, the pregnancy chapter, that will cover hypertension with pregnancy. And depending on the patient's age, if it's neonatal hypertension, it's a different chapter, and post-procedural hypertension is yet another chapter. But in SNOMED CT, it's much easier to find all the necessary codes because they would all be subsumed under hypertensive diseases. So another advantage of SNOMED is that data retrieval is easier because all the things, most of the things in the clinical finding hierarchy, they are defined by attributes, right? So you can retrieve all the necessary things that you want by your logical definition through the attribute-based query. So for example, if you're a researcher, okay, you want to look at all the diseases that are caused by occlusion of the arterial supply to an organ, but you're interested in everything but diseases that affect the intestines and the kidney for some reason, right? Your research doesn't cover those two areas. So how do you do it in ICD? So you probably have to look through the in-text carefully, and you have to go through the different chapters to make sure you're not missing any codes anywhere, right? But in SNOMED, there's an easier way to do that. And that is the ECL that we're going to show you. So this is based on the clinical findings attributes. This is the all the things, the attributes that are used in the clinical findings hierarchy, and we'll make use of some of this to do our query.
Remember earlier, machine readable concept model? These are the defining attributes in it for clinical finding, okay?
Mhm. So I have a list of exercise, and I think, Jim, you're sharing our slides, right? And also the ECL exercise.
Yep.
I think for the interest of time, let me just focus on number 6, which is the example I've given for the researcher who are interested in certain arterial occlusion disease, but except certain body parts. So can you?
Yeah, sure. Yep.
Yeah, just the browser will be okay.
Oh, the browser's okay? Okay. So this is the browser?
Yeah, okay, so we're showing the browser.
Yep.
And then, and we'll clear the previous. Oh, okay.
Yeah.
It's easier than I thought.
I might convert a whole lot of people to Mac.
Okay. So if I want to go back, I'll just do
Command and tab, but
command and tab.
Yeah.
Okay. Okay, I'll try to do that. Yeah. So
As you can see, interoperability is in the details.
tap and tap again. Okay, and then I can touch.
Yeah. I'll stay.
Okay.
Just in case.
Okay, so first of all, we want to have all diseases that are self or descendants of arterial occlusion of artery disorder. Tap.
Oh, you can just. Yeah.
Oh, okay.
Yeah.
Okay, and then for refinement, we'll
Just press. Just
Oh, press.
give it a little
Oh.
click. Yeah.
oh, okay, press instead of tap. Okay. Oh,
Yep.
okay. So for the refinement, we'll want to use the clinical attribute, which is we'll use self. So we'll use the attribute finding site. We want to exclude things, so we want to say the finding site is not equal to. So here is the value that you want to exclude. So again, we want to exclude a parent concept, but we also want to exclude also the descendants of that concept, because we're not interested in things that affect the kidneys. So we say, so structure of renal artery, right, is one thing that we want to exclude. And another thing we want to exclude is diseases that affect the intestine. So self. Finding site again. And here we want to find in test time. Okay, maybe it's okay. 3. Okay, so the advantage of being clinician is you know, okay, intestine artery, another name of it is mesenteric artery. So you would say, okay, mesenteric artery. And then here is your, so you go back to the execution.
Yep, we can just scroll.
Oh, okay.
Down 2 fingers.
Oh, 2 fingers to go. Okay, so here in the box is the ECL query, and you can then just execute it. Let's see what concepts. Oh, I know what's happening. It's not equal, is not working. Let's all change back to equal. Okay.
Scroll to the other way.
The request calls on, okay, let's see. It's good to have some errors, then you know, you learn more. Okay, now you find the 209 concepts like celiac artery occlusion, right subclavian artery occlusion, and that all that. So that's this.
What would happen if you specify it more broadly, like exclude the intestine structure as a structure, not specifying the artery?
Okay,
And
that's
the kidney structure and not specifying the renal artery.
I think that will probably not work because the way the concepts are modeled is based on the artery. Oh, okay.
So, without having the entire hierarchy in my head, I would guess that it actually would work because the arteries are
It's subsumed by-
structures are part of organ structure, which they are.
Oh, okay.
So but you have to see if that.
So you try that?
209 because it could be those which are arterial, but also disorders
Within
of other
another-
structures.
okay.
Of the heart.
Okay, so yeah, you're absolutely right. Okay. Good. So thank you for pointing that out.
But you clearly get the point of how the meaning of what he was looking for has basically been extracted from SNOMED CT. And we'll give you some more examples. Go ahead,
Yes.
Ken.
So there was a question from the on-time part of the audience. And would it be possible for questions in the room to be transcribed or posted to the QA? And maybe I should choose the mic.
Yeah, so hopefully this is working. Yeah, and so I'll try to make sure that when we ask questions, I'll run around with this.
Well,
Make sure
can
that
we-
the friends online
can
can
we
hear
j-
us.
We can do a verbal, a voice to text on screen. I've seen Zoom do it. It'll keep a transcript. Can we get Allison to look, or Scott, could you see if you can get the staff to turn on transcripts for this? Thank you.
So yeah, look, I'll make sure I'll run the microphone around.
I will try to paraphrase the questions in the chat and hope I get things right.
So my question is related actually to this, to the other point made, deciding on the focus concept. I mean, is the general guidance to pick a concept that is going to most quickly subset the value, or I guess subset's not a good choice of words, constrain to the set of values of interest, because you could just as easily start in many cases with, you know, the finding site and then do some different type of refinement. So what is the guidance for picking the focus concept?
Yeah.
I mean, I think I would say that obviously SNOMED CT is authored based on picking the most like a proximal primitive concept, so as far up the hierarchy as possible, and then you provide a large number of refinements to get you to what you want. But it does require you to say quite a lot and to know quite a lot about the modeling to make that work. I think it depends what you're doing, but for analytics purposes, I mean, if you were trying to say acute appendicitis, you could start all the way up at disorder and do all of these things, or you could just say appendicitis plus acute, which is probably where I'd go.
Kinwa,
I think we can move on. Yes. What time?
20
Okay.
to go.
So how do I go back to the presentation screen?
Just
A command tab. Okay, all right. So we don't have time for additional examples or exercise. So I'll move on to talk about some resources that the NM has created. One that's called a core. Okay, thanks. Okay, so this is the one thing that we created is called a core problem list subset of SNOMED CT. So it's based on real data with usage frequencies from 8 healthcare providers. I won't read them here. So the data cover altogether 17 million patients from all major medical specialties. So it's updated twice a year now, and it covers the most commonly used terms that will cover at least 95% of usage in any individual data set. And this is a breakdown of the latest. The total number of concepts is about 6,000. And it also includes procedures because some institutions do have procedures in their problem list. So the use of the core problem list subset, I mean, people can use it to help with the implementation and can help to focus quality assurance activities. And people have used it in mapping as well. So the next, I'll change gear here and talk about how SNOMED can interact with ICD, right? So ICD codes will still be around and are going away. So, so one idea is to create a map between SNOMED CT and ICD. So what are the benefits of such a map? What will it do? First of all, I mean, we can reuse clinical data that is encoded in SNOMED CT to generate administrative codes in ICD, right? And the second biggest use case is data integration. Now with the data analytics and data and big data. So you very often you have data sources coming from different sources, and they are encoded in different terminologies. So it can be encoded in ICD or SNOMED. So if you have a map, then it's easier to pull the data together. And with a map, sometimes you can see that deficiencies or defects in one system when you're mapping things that can also lead to improvement in the coding in the quality. So this work of mapping started around 2006, and we have a mapping special interest group, and that has resulted in the creation of 2 maps, right? One is the map from SNOMED to ICD-10, and the other one is SNOMED to ICD-10-CM. The first one is maintained by SNOMED International, and the second one is maintained by NLM. So the scope of mapping, 3 hierarchies, clinical findings, event and situation with explicit context, totally over 120,000 concepts. And the map now is almost, we can cover the full scope now. We started in 2012. Now, I mean, it's more incremental to map the new concepts. So it's a rule-based map. So because often things are not one-to-one, and there are two types of cases in which there's one to many, right? So there are 2 situations, right? One situation is one SNOMED concept. You need a combination of 2 called ICD codes to capture the full meaning. And the other example is the other type of one-to-many map is an OR situation, because for one SNOMED concept, you can have a number of alternative ICD-10 codes that you can use. So I'll give one example of each. So N is the etiology and manifestation example, like anemia and ovarian cancer. You need 2 SNOMED codes, ICD codes to cover the full meaning. So this is an N situation, the first example. And now it's the OR example, like gender. For example, unexplained infertility in SNOMED. Depending on patient, whether it's male or female, you can have different codes, right, for them. So this is an OR situation. So we imagine that the map can be used in interactive generation of ICD codes in a use case which we call iMagic. So I won't go through the scenario, but I will refer you to this iMagic demo site, which is like this. So I have a number of screenshots, which I'll go through really quickly. So if you go to the iMagic website, you'll see this. And the thing in the red box is things that are usually in the EHR, name, gender, date of birth, right? And the user can type in the problem, and then there will be a list to pick from, okay? And when you finish the problem list, then you can click the Get ICD codes. And based on the map behind, it will get the list of ICD codes, and you can have refinements like laterality refinement or other refinements. So to showcase the rule-based map, you can have, so you can have a code in SNOMED, failure to gain weight, which have different codes like in ICD, depending on the age of the patient. So this is an adult code, which is R62. If you change the age to a child, you have a different code. And if you change to a newborn, you have another code. Same for gender. This is the male code for herniated urinary bladder. And if you change it to female, you have another code, okay? So you can also look at the codes on the browser. If you look at the SNOMED browser and the ref sets, you'll see that one of the websites will be the complex maps, and you showed you the maps to ICD or ICD-10, ICD-10-CM. So can I use 3 more minutes to go through ICD-11? Okay, so ICD-11, so it's the next big thing in ICD world, right? So ICD-11 is adopted by the World Health Assembly in May 2019. So the first release in February last year, and it has now been used by over 35 countries, according to the WHO website, used for cause of death, primary care, cancer registry, and so on. So what is new, right? Of course, every release or every version of ICD will have some incremental changes, like more codes, new chapters, and so on. But there are important things that I would call paradigm shifts in ICD-11, which I'll go in slightly more detail, like foundation component, post-coordination, and going digital. So how big is ICD-11? So if you only compare the same chapters in ICD-11 and ICD-10, there's about a 20% increase in the number of codes, not a huge lot, because there's some new chapters in ICD-11, like traditional medicine, functional assessment, and extension, which are not in ICD-10. So we don't compare those. So overall, if we compare like with about 20% more codes. So new chapters, like some of them are splitting of old chapters, like disease of blood at blood forming organs and so on. Some are really new chapters, like sleep-wake disorders and sexual health. So 3 important major changes in ICD-11 is the ICD Foundation, which is a knowledge base from which classifications or what they call linearizations are derived, right? Because it's frequently updated to keep, so the foundation can be updated more frequently, but the proper classification codes, they're released every year, okay? And this foundation is structurally akin to an ontology, like proper terminology. So it can have multiple parenting, and there's no NOS or NEC things in it. So this is just 2 wheels showing the orange one above is the foundation. So we can see that there's multiple parents shown in this concept of cerebrovascular diseases, right? But the blue thing underneath is the linearization, and it's only 1 parent. So that is the difference between the 2. So another big thing in ICD-11 is that it allows combination of codes, like SNOMED, right? We have post-coordination. So post-coordination is now allowed in ICD-11, which is called code clustering. You can combine 2, what they call stem codes or main codes, or you can combine a stem code and a modifying code from the extension. I won't go into detail with that. So the third big change in ICD-11 is that it is very digitally friendly. So it's browsers, coding tools, and APIs. Okay. And rumor has it that ICD-11 may be the last major revision, right? So because of the constant update that can be done to the foundation, so you might not need another major update like ICD-11, right, to capture all the advances. And there's also another rumor that WHO might not allow countries to do their national extensions, but this is still very much up in the air. So this is my last slide. And so there's an ongoing project going on between SNOMED International and WHO to create some kind of a map between the two. Basically, it's mapping from SNOMED to the foundation of ICD-11. And the project covers number of concepts and codes for the endocrine systems, and the results are still being analyzed. And the future direction this will take, we don't know yet, and it depends on discussions between the two organizations. I think that's the end of my presentation. Thank you.
So we've got one question for Ken on the internet. Make sure I'll respond to that, Ken.
Can someone read the question?
So the question was, iMagic is, or is that what it's called? iMagic?
Yes.
Yeah, it's open source. If yes, please link. And I provided the link to the
okay.
tool you were showing on the presentation. Do you want to comment on that?
It's, I mean, the question is about the link?
So first, is it open source?
Oh, it is not open source because it's not a script or any program that you can run. It's based on, it's basically a demo tool to show how the map can be used. There's no API or there's no way for local installation. So it's not in. Okay.
Thank you, Kinhwa. So Kinhwa has basically discussed the use case from the standpoint of a public health policymaker. Okay. Purpose of ICD series is basically it's created by WHO for worldwide reporting of morbidity and mortality. And features that we have in SNOMED CT support reuse from the clinical environment where you're recording it in your data in your EHRs to the public health sector. I'd like to move on and talk a little bit about use of clinical data in research. You know, we had an event in the United States around 2011 called Meaningful Use, and all of a sudden, we had a lot of electronic health records reporting information. It was standardized and coded in what were the standard coding systems, as Kinhwa pointed out, SNOMED CT for problem list. One of the research endeavors we got involved in at Nebraska is called PCORnet. They're basically a network of data marts from electronic health records nationwide. So we've got 150 or more care sites and universities that are basically contributing data to this network. And it's distributed in that basically everybody keeps their own data, but they structure it in the PCORnet common data model. Remember the top level ontology I talked to you about earlier? Okay, well, PCORnet defines the common data model and tells us what are the classes, or actually they're SQL tables that we maintain. And one of them is the condition table, which is the top level model for the problem list as we extract it from the electronic health record. And in the condition table, all of the data entries in terms of what is the finding or diagnosis that is being referenced in the condition record, okay, whether it's an active problem or a resolved problem or whatever, basically is SNOMED CT. So with this top level ontology tells us how we need to organize the data for public health. SNOMED CT is basically providing the vocabulary or domain ontology that defines the meaning and details in what those conditions are all about. So, you know, for example, a query in sort of plain text language, you know, that we would receive from PCORnet asking for send us a list of all your patients with diabetes, okay, means that we would query our condition table, our condition records looking for conditions of diabetes, which we would translate into a query on SNOMED CT. Thinking about that expression constraint language you looked at earlier, it would be something like self or descendants. That's what that double less than sign means in ECL. 4405 4006. That's the top level node for diabetes mellitus in the disease hierarchy. All right. And we recognize the fact that our clinicians record that a lot of ways, some more specific than others, like type 2 diabetes, et cetera. Well, this query will basically grab all the relevant SNOMED codes that pertain to that query. What are the diagnoses in your system that correspond to diabetes mellitus? Okay. Early in the research endeavor, trying to get together with 150 clinical data sites, we realized that these queries had to be standardized. If we allowed each and every data mart manager to write the query to answer the question, we would get probably a lot of different answers because of the fact that there's varying levels of expertise with SNOMED, understanding of the concept model, and the ability to basically find that list of codes that correspond to diabetes mellitus, which is basically risen in the research literature in something we call a computable phenotype. And basically, it's a reproducible query that defines a set of clinical conditions that identifies the cohort of patients you're interested in, okay? And in the example that I gave you, find all of your patients who have diabetes mellitus. It's precisely any patient who has in their record an active condition with one of those codes that come back from that ECL language. So we actually use ECL queries, okay, to basically identify the relevant code sets. We sometimes call them value sets in the research community that apply to a particular query, because when you're querying against these tables, you can't just say diabetes. You got to be specific about what do you mean by that. And so a research computable phenotype basically standardizes that query across a large group of cooperating individuals so that they can get uniform and reproducible results from their data mart. Now, I want to use 3 different examples. These are all papers that we have published in the last 2 years, okay? The first one, the hypothesis was that adult patients with alcohol use disorders are infected with COVID-19, are more likely to die from their illness. Now, there's a number of features in that query. Yeah, I mean, we'd be querying for outcomes, we'd be querying for the inclusion criteria in the cohort so that we could identify the patients, et cetera, okay? But let's just talk about the inclusion criteria for a second. And in particular, what does it mean to have an alcohol use disorder? All right, it'll come back to me. Yeah, that's what I want. Thanks, Scott. I really appreciate that. So I'm going to, there we go. Let's clear out this, okay. So alcohol use disorders, what does that mean? Well, first of all, I would point out that it is a disease, okay, or a disorder. Disease, disorder have equivalent meanings in the SNOMED CT clinical findings hierarchy. And as you know, clinical findings is basically a lot of disorders, a lot of diseases, and a lot of findings all arranged together ontologically because we couldn't figure out a uniform way to separate findings and diseases. It was too darn complicated, okay? So let's start off by saying, okay, it's a disease. And what do you think it means that it was caused by alcohol use? Just the act of drinking is what did it, raising your elbow or something like that? I would suggest to you that it means that alcohol is actually what was causing the set of disorders, okay? That's my interpretation, and actually that's the interpretation we came to as a network. And in the concept model for clinical findings, there is a relevant attribute to what causes something. What would it be?
Causative agents. Causative agents.
Very good. Scott, go give her a sucker.
Be a causative agent for diabetes.
Okay. And in this particular case, it's basically caused by a chemical, right? Ethanol. Okay. Which in SNOMED would basically be a substance. Maybe it likes ethyl alcohol better. Yeah, now you finally get it. Okay, so this actually is the computable phenotype definition of what alcohol use disorders were in when we ran that project. Okay. And I think the first thing we should ask is, does that really make sense? Let's take a look at the concepts and two side by side and scroll down.
Yeah, yeah, 2 fingers. So, yeah, that's it.
Okay. Okay. Damn. Can you go back?
Yeah. Yeah, there you go.
Okay. So alcohol dependence in childhood, alcohol dependence in pregnancy, intentional poisoning by ethyl alcohol, alcohol-induced disorder. And if you look down this list, you find things like alcoholic cirrhosis, alcoholic hepatitis, all of those things that SNOMED and incidentally the SNOMED editors have defined those concepts to mean, okay? They're caused by alcohol. So this is a very simple example from the standpoint of the ECL query. Some of them are not so simple, okay, depending on a lot of factors. But the point is, this is I'll tell you, if you ask people to go in and pick out the codes from SNOMED as to what's relevant, it'll take them a long time because it's really not designed to be hierarchically searched. It's designed to be logically searched because of the a concept model and the logical design behind that. Let's take another example. Patients with documented coronary vascular disease at high risk of complications are uncertain as to the best dose of aspirin for preventing MI. We just published this recently, and I got my name in the New England Journal of Medicine for the very first time in 50 years of practice, would you believe? So I'm rather proud of this study. It was called the Adaptable Trial. And there we go. If you take a look at that, of those ECL doc.
Yeah, 2.
Okay. These are the ECL queries that I've published with the, here we go. Separation, go to the section on interoperation for clinical research, okay? And here you'll find what I had for Coronary vascular disease, can you?
Copy that. That one?
Yep, that's fine.
Yep.
You got it?
Yep.
Yeah, I know I'll have to edit it.
Oh, sorry, did I miss part of it?
Don't worry about it. Oh, now we gotta,
No.
okay. And now I know this is a little confusing from the standpoint of the way it's constructed. You can put comments in the ECLs and the queries, but they have to be, separated off with this slash asterisk slash, and then the compiler basically ignores them. So here's the ECL that I'm going to use. First of all, we're looking for self or descendants of disease. Okay. A finding site of a coronary artery structure. All right. And then when we run that query, what you get is also some congenital coronary vascular disease, misplacement of the coronary arteries and things like that. So I'm going to accompany it by an associated morphology. Does anybody know what associated morphology is in the concept model? It's basically what the pathologist sees if they actually cut the coronary artery and look at it under a microscope. The morphology is basically the pathology that's in the coronary artery. So we're saying there has to be an associated morphology of arterial sclerosis, which is basically our garden variety arteriosclerotic coronary vascular disease. Okay. And when we run that particular query, okay, does it look like we got what we wanted? Coronary artery disease due to type 1 diabetes, coronary artery disease due to type 2 diabetes, including things like unstable angina and coronary arteriosclerosis after angioplasty. So I think on face value, you can appreciate this is cherry picking, if you will, out of the immensity of SNOMED CT clinical findings, those diagnoses that are relevant to this particular use case. Daniel, you got a question or?
If I may, I have a small comment. When I do this similar things, I'm a bit nervous that I missed something. So what I usually do is that I find a more generic concept, and then I take that and extract the thing I'm looking for, and then I'm seeing what other things I didn't get, and then I could filter by text to get. See,
No,
is there
and
any
I think your point is very well taken, Daniel. Any good data mart manager will basically run this analysis and the list of choice of codes past their clinical expert community, okay, and get a separate validation of it. Some more often, some more so than others. What?
Yeah. The specific point that you could actually use ECL for doing that analysis as well as creating the value set. Thank you.
I see. Well, we'll let you show that later, Daniel.
So another comment I have is, Jim, you can pass your list through your clinical experts, but they will not know what they're not seeing, right? You may be missing things that you have not included in your list.
You're absolutely correct. And so if you want to be meticulous, you query more clinical experts and basically ask them to come up independently with diagnoses that they think fit the bill and see if for any reason you missed them. If you do, then of course you go back and reevaluate your logic and SNOMED CT. I mean, it's still evolving, it's still getting better, but I can tell you from personal experience that is pretty damn good today. Where are we? Third use case that I want to mention, patients with advanced colorectal carcinoma residing in rural areas are less likely to be treated with molecular cancer therapies than those in urban areas. Okay. And what about colorectal cancer, carcinoma? I'm down to 2 minutes, so I'm going to just explain my query rather than painfully go through editing it all. Okay. So in doing some of the due diligence that exactly is what Daniel described, I wanted to find cases of colorectal carcinoma. Can you read this okay? All right. So we started basically with malignant neoplastic disease. That's cancer disease, okay? If you take a look at the definition, it's an associated morphology of malignant neoplasm, okay? And it's a disease. And then I added finding site of colon structure. I was thinking, well, the rectum should be included in that, right, Daniel? Went ahead and ran that, okay? And when I looked at the list, I found that if you actually go to the SNOMED CT body structure anatomy, basically, all right, and review it, you find that rectum actually isn't a child or grandchild or whatever of colon structure. Okay, so I revised my my final ECL, and you said you just do that, huh?
Yeah.
Oh,
Knew that.
that's painful. To be, and here you can, ECL allows you to basically use logic, okay? And I changed it to descendants or self of colon structure or of rectum structure, because rectum was not actually a subtype, okay, of colon structure in the body structures. And this is part of the due diligence you do as well. When you come up with conflicting answers or something that's curious, then you go in and take a look at the hierarchies. In this particular case, you go to body structures and look up your colon structure, and then look at all its children and all its parents and find out how you're going to pull in those rectal structures, okay? And I went from 62 SNOMED CT concepts in the international release to 94 in this modified query, which is a simple modification once you begin to, think logically about how these things relate together. The description logic classifier basically uses the relationships, the axioms in each and every one of the major hierarchies to answer the question, such as in this case, we want cancers, we want them from the colon or rectum, and it'll give you the answer once you're speaking the same logic that it is. Okay. And I think I'm at the end of my time.
Question. There is a concept that is malignant neoplasm of colon and or rectum, which finding site is structure of large intestine. And this kept me thinking if the large intestine includes both rectum and colon. And if we could go.
Well, thank you for that insight. I appreciate it.
I'm not sure. I'm just asking.
No, that's terrific. And anus. Yeah. So no. To go back then, I mean, that was a good insight on your part. But, unless you're a trained clinician, oncologist, you would go ahead and then ask the oncologist if in fact cancers of the anus should be included in that, okay? And then that would basically allow you to conclude what sets you want a query on. Good insight, good insight. Okay, I want Olivier to come up here, please. For those of you who don't know him, Olivier Bodenreider is director of the Lister Hill Center, correct, Olivier? For the National Library of Medicine, and he's an ontologist extraordinaire. And he and Dion are going to be talking about some details of the medication model in the next hour. Olivier?
Can you specify how much time we have again?
Well, I think I gave it, yeah,
Half an hour.
30 each.
Yeah, when's the break?
It's in half an hour.
Yeah, so probably break after yours.
Good afternoon, everyone. So as Jim said, I'm Olivier Bodenreider. I'm with the National Library of Medicine. And before the break, we're going to go through two elements of interoperability regarding medications. It's going to be relatively superficial because there's a lot of information. A lot of the slides that I've included in the presentation are for reference more than they are for going in detail with, because otherwise we would need to spend the entire evening, and you may not appreciate all this. So we're going to do two things. We're first going to look at the SNOMED model for medications, and then we're going to look at the RxNorm model, which is what's used in the US, and we're going to try and contrast them and see how interoperable they are, because that's what we're talking about today, interoperability. And following my presentation, Dion is going to present something similar, but with Australian medications, which is going to give you a broader view and a broader set of challenges regarding interoperability of medications. So these slides have been adapted from presentations that I've given in the past. The first one is about the SNOMED international model for drugs, the SNOMED CT international medicinal product model, as they call it. And I didn't create it. It was created by a team. We presented this back in 2018 when the model went out with Judy James. And if you want to go back to something more in detail, there's a paper and for which you have the reference here. So amlodipine bisylate and atorvastatin calcium tablets, 10 milligram per 10 milligram. Or 10 milligram/10 milligram, I should say. This is a medication that you can buy in the US. And essentially, this presentation is going to be about how do we say this in SNOMED, okay? And seems pretty easy. I mean, looks like there are two active ingredients or something. We know how much of it there is, and looks like it's a tablet. So, I mean, we have the essentials, and it doesn't look like it's very difficult. Well, wait a few minutes and we'll think again. So before 2018, there were medications described in SNOMED, of course. But they were described in a way that was not always consistent. And the things that were presented were not always what we now know what needs to be represented. So for example, there was this notion of amlodipine 10 milligram and atorvastatin 10 milligram oral tablets. is this what we should say, or should we say amlodipine becylate, because they specify a modification of the ingredient here of the substance, and same thing for atorvastatin calcium. So first question here, and I'm planting doubt in your mind, and these kind of things. So these are the kind of issues that we need to look at when we want to represent medications. By the way, here, there was some kind of definition provided by SNOMED. It was not a sufficient definition. It was just necessary conditions that were provided here. There was no equivalence. The 3 bars, that are the symbol for equivalence. And in the description, we see amlodipine becylate, good. Where's the atorvastatin? So it's in the FSN, if you wish, it's mentioned in the FSN, referred to as amlodipine. We lost the becylate in the FSN. I'm not saying it's wrong. I'm just saying, there are all these discrepancies, and that's precisely the reason why SNOMED needed to create a strong and principled model for medications, and spent a few years retrofitting all the medications to the new model such that they are described in a systematic and consistent fashion. So among the issues there was no notion of strength. We lost the milligrams here. Of course, as I mentioned, this is not, there are no sufficient conditions, so we cannot compute equivalence with other or subsumption with other medications. There's really nothing that says here that there's no aspirin in this medication. They say there's amlodipine becylate, but there's no closure to say that there's only amlodipine and atorvastatin, for example, which is a big thing with medications, because you want to know what's there, and you want to know that only what's there is there. So some of the issues that existed with the prior model. And so that was the motivation for creating a stronger model. I essentially said pretty much what's on this slide, so I'm gonna skip it. So medicinal products in SNOMED, there's a few notions that we need to have. As you probably know, the medicinal products are distinct from the substances. So atorvastatin, the substance, and atorvastatin, the product, both exist in 2 different hierarchies. They are intimately related, but they are distinct. So that's one thing to keep in mind. And of course, as Jim mentioned earlier, what links all the bits of SNOMED together are these relationships and or axioms when we look at them from the perspective of OWL. And now we know that medicinal products have substances as their ingredients. That's the relationship between the 2. So there are a few types of medicinal products that SNOMED defines. One is the clinical drug, when that includes an ingredient, a dose form, and a strength. A medicinal product form, when it's the ingredient and the dose form, and a medicinal product when it's essentially just the ingredient. In addition to that, SNOMED also defined drug classes for chemical structure, mechanism of action, essentially, which they refer to as dispositions, and therapeutic classes. I'm not going to go too much into the drug classes because we have limited time. And one thing that's important to keep in mind also is that SNOMED, the international edition, drew the line pretty much at what's common to most extension, or what forms the foundation for most national extensions. Which means that SNOMED was not going into describing every, collecting every brand name from every country and include this into the international edition because that wouldn't be of use for many countries. So this is left for building national extensions, and SNOMED, the international version, provides a foundation for deriving these extensions. The use cases that are supported include international interoperability of medications at the level of generic drugs, we could say, no brands, no things like this. It provides a foundation for creating national drug extensions to support analytics. Usually when you do drug analytics, you don't care very much at the brand level. It's mostly rolled up at the generic level. So it's essentially at the clinical drug level, and SNOMED supports that. And of course, with the addition of drug classes, it also provides information for building decision support systems related to medications. I've said this, but I'm going to show it here again because it shows essentially the 6 types of medicinal entities that are defined in SNOMED. And maybe I'm going to show you this version, which is the same thing. So the medicinal product refers to the ingredient, and there's 2 versions of the medicinal product, depending on whether you talk about all the medications that contain atorvastatin, which will include atorvastatin and amlodipine, or you want to know all the medications, all the clinical drugs, for example, that contain only atorvastatin, because there's a huge difference between the 2. So that's why there's 2 copies, if you wish, of this medicinal product entity. Same thing with the medicinal product form, which adds the dose form essentially to the ingredient. And the clinical drug at the lowest level here defines the conjunction of the ingredient, the dose form, and the strength. And I'm gonna leave aside the precise only because it's optional, and these 5 are the core here. So the major distinctions, so the major elements to keep in mind here are horizontally, the 3 levels, depending on what time of defining features you have. So medicinal product, it's defined by the ingredient. Medicinal product form, it's defined by the ingredient and the dose form. Clinical drug, you add the strength to that. And the distinction vertically between the onlys and the others is when in the onlys you add the closure to make sure that there's nothing else than what you see there, okay? Nothing else than what's stated as an ingredient. So this is another view of pretty much the same thing, illustrating the example that we started with. So this is amlodipine and atorvastatin. So at the medicinal product level, they are defined as base ingredient, not modified. Okay, so it's atorvastatin and amlodipine. At the medicinal product form, that's pretty much the same thing. When you reach the clinical drug level, the lowest level, it's important to refer to not only the active ingredient or the base ingredient, as was mentioned in the medicinal product, but to the exact ingredient, the precise ingredients that is used to define the strength. Because you remember the difference between a clinical drug and the level above is the addition of strength. So when we say 10 milligram, it's of which is this 10 milligram? Is this 10 milligram of atorvastatin, or is it 10 milligram of atorvastatin calcium? And what we learned here is that it is 10 milligram of atorvastatin calcium, because that's what's defined on the label, if you wish. However, what you find in the, it's 10 milligram of atorvastatin. However, the 10 milligram of atorvastatin come on the form of atorvastatin calcium. That's what's in the pill, okay? So there's more than 10 milligram of atorvastatin calcium, because the calcium weighs something, but the strength is expressed in reference to atorvastatin. Okay, so that's all the complexities, that's some of the complexities that are part of the model. I'm gonna skip this because I've said most of it already. I'm gonna skip this because this is mostly a description logic kind of issue. The issue here is, how do you say only? There's only atorvastatin and amlodipine. There are ways of saying this. There are elegant ways of saying this in OWL. There are actually specific ways of saying this. The OWL profile that's required to say there's only this is not supported by the profile that SNOMED uses to define SNOMED CT. And for this reason, they need to find another way to say there's atorvastatin, there's amlodipine, and there's nothing else. And the way that they found is not the most elegant necessarily, but it works, and it allows tractability, I mean, which is computation in limited time, to occur when SNOMED gets classified. And so the trick, if you wish, that they found is to say, well, okay, there's atorvastatin, there's amlodipine, and there's only two drugs. There's only two ingredients, okay, which excludes the presence of something else. So it's a kind of trick because they couldn't say it in the way you would say it in OWL with a higher level profile. If you're interested, this is the OWL speak, if you wish, for this very medication that we've been talking about. And as you can see on the very bottom, the way to express the closure is to say the count of base of active ingredients is 2. So 1 for atorvastatin, 1 for amlodipine, which doesn't leave any room for anything else. I mentioned that SNOMED created groupers, which are these drug classes, based on disposition, which is mechanism of action. So that's where it says that atorvastatin, it's how you can say that atorvastatin is a statin, with a complicated name here, HMG-CoA reductase inhibitor, but that means statin, or based on the chemical structure. So we can say that some product is an aminoglycoside, or based on therapeutic roles. And the therapeutic roles are not all defined, and they are being redefined, which means that they are not consistently defined at this point in time. So this is when you put all this together, and when you want to look at things in a graphical way, if you wish, that's what you're gonna look like. And it's a simplified version because I didn't represent the only versions because that was too complicated. But that's essentially the big picture that you get when you look at the clinical drug and its ancestors with the various levels, which I've tried to code with colors in this particular case. Just an illustration of what you see here. In the interest of time, I'm going to skip this. It takes a village, you can imagine, to create something like this. And essentially, it was all hands on deck, as you can recognize here. Many people contributed to the drug model at that time. So if you want to experience it for yourselves, you can go to the browser. We won't have time to do it just now, but you can go to the browser and search. What I would advise you to do is search for a clinical drug that contains atorvastatin or amlodipine. You can do this with ECL, but you can do it just with search. I mean, I would start just with search. And you navigate to the clinical drug. And what's interesting is that, well, you will find it. And that's exactly what we've looked at earlier. You find the definition because it's a fully defined product. You see the 3 bars here. All the drugs have been reorganized, if you wish, and refactored so that all the product hierarchy is actually fully defined at this point. So these are the definitions. And if you're curious and you look at the parents, you're not going to see the graphical picture that I gave you, but you can still find, if you look closely, you can still find the various levels that I've mentioned. You find the MPF only, product containing only amlodipine and atorvastatin in oral dose form. You find the medicinal product only, the dose form is dropped. And you find the medicinal product, which is product containing amlodipine and atorvastatin, which doesn't exclude that some other ingredients can be in a particular medication here. Okay, so that's the diagram. You have all this online in the SNOMED browser if you're interested in checking all this. Any questions before I move to Rx norm? Okay, so it was extremely clear, or you're all stunned? Okay, thank you. Mike, please.
When you mentioned I think the drug groups, there's the WHO ATC classification is included in the SNOMED model for the medicinal products?
So short answer, it is not. Longer answer, there are parallels, of course, between the classes in ATC, the anatomical, therapeutic, chemical classification that's developed by the WHO, and an equivalent class or similar classes in SNOMED. I'm going to show you something now where in the same product in RxNav, you can actually see ATC and the ATC classes and the SNOMED classes. Isn't it cool? Please just say yes. Okay, so let's move on to RxNorm now. So RxNorm is the reference that we use for medications in the US. And we wanted to compare, it also has a model that's kind of like the same as the SNOMED model, but at a very high level, it looks the same. We wanted to see what the differences were and how interoperable they were, because it's not just an academic exercise to say, well, you know, there are these differences, but does it matter at the end of the day, and how compatible are they? So that was the question here. I'm going to breeze through this fairly quickly. So yeah, we wanted to see the similarities and differences and look at implications for interoperability. I can save you the background on SNOMED and the SNOMED model because we just spent a good amount of time on it, but it's just another example that was simpler because it's only one particular ingredient here. So what's RxNome? It's the US standard for drugs. It's developed by our home institution for Quinoa and I, the National Library of Medicine. It's a simpler model compared to SNOMED. But it has the same bits and pieces, if you wish. You find the notion of an ingredient, the notion of strength, and the notion of dose form. And these are the three main elements that are required to define what a clinical drug is. It's, you know, it makes sense that we use the same definitional features. In addition to that, there's two optional features in RxNome. One is what's called the quantitative factor. So when you have a syringe or a vial and you know exactly how much of the product there is, what's the volume is added as a quantitative factor. Now I'm going to go back to that a little bit later. And there's also room for qualitative distinctions. If you want to say that something is sugar-free, it's not definitional. It's not going to kill someone, I guess, that the product is sugar-free or not, but it's important. It's an important distinction. Abuse deterrent is also really important, of course. And there's a huge opioid crisis in the US that you might have heard about. So the scope includes both generic drugs and branded drugs, which is different from the scope of the SNOMED international model. So you can think of it as the national extension, if you wish. If it had exactly the same formalism, that would be the national extension for the US. So we have an ingredient, for example, cetirizine, and there's a code for that. And that's the equivalent of the medicinal product to some extent. There's the notion of an ingredient and a strength combined together, which doesn't exist in the SNOMED model. For example, cetirizine hydrochloride, 10 milligram, and the clinical drug component, as we call it, refers to the precise, because of course, as soon as you have the strength, you need to refer to the precise ingredient, because the precise ingredient gives you what's called the base, refers to the basis of strength substance. Clinical drug form, which is essentially equivalent to the medicinal product form when you add the ingredient and the dose form, and the clinical drug, which includes, again, the ingredient, the strength, and the dose form. So similarities, I just mentioned them, same definitional features pretty much, except that in RxNome, there's not this notion of only. They don't do the same closure that SNOMED does. So that's an important distinction. It's implied, which means that it's not, we cannot compute against it in the same way. It's not as rigorous, if you wish. And another distinction is that RxNome doesn't distinguish between, doesn't have two copies of everything, doesn't have atorvastatin, the substance, and atorvastatin, the product that contains the substance. It smooshes them, that's a technical term, smooshes them together and into one entity. And so there's only one atorvastatin. And depending on the context of use, you know, if you're talking about the medicinal product or the substance that is contained in the medicinal product. So it's a simpler model with implicit information, whereas SNOMED tends to make things more explicit, which is a good thing, I should say. There's also the notion of substance modification. It's expressed differently, but there's the notion of precise ingredient in RxNome that's somewhat similar, except that there's two different entities, one for the base ingredient and one for the precise ingredient. Whereas in SNOMED, it's really the same substance, that it's the substance type entity that is linked by a modification of relationship. We all go back to the relationships that hold everything together in SNOMED. I don't think I have much time to go into the distinctions in terms of concentration strength and presentation strength, because we're getting into things that are complicated. These are equivalent, if you wish. So if you know that there's 2 milliliter of a 10 milligram per milliliter substance, if you do the math right, which I usually can't, you know that there's 20 milligram over 2 milliliters. Okay, whereas so SNOMED would say 20 milligram in 2 milliliters, and RxNorm would say, well, there's 2 milliliters of a substance which concentration strength is 10 milligram per milliliter. So math can help solve these kind of things. I'm going very quickly through these kind of things, but this is essentially the overview that shows the correspondence between RxNorm and SNOMED in terms of definitional features, from which the correspondence between the main types of entities can be computed. I make it sound simple, but of course, for many medications, it's easy, and for the tail of the distribution, it's much more complicated. And Dion is actually going to give you examples of some of these detailed, intricate differences that
That's the trade name.
we need to think about. Okay, so if we want to look at it, the SNOMED model is more rigorous. It is better aligned with international standards. I didn't mention this, but the dose forms are aligned with EDQM, which is an international standard. The notion of closure, that a clinical drug needs, you need to say exactly what's in there and what's not, what cannot be in there, because you're saying only. This also comes from a requirement from IDMP, which is one of these other standards. So SNOMED is better aligned with international standards. But at the same time, it's a more complex model, so it's more difficult to get it, if you wish. Whereas RxNorm, contains implicit things, but at the same time, it's easier for people to get it. So I would say that there are pros and cons. SNOMED is easier to compute with, of course, you're guaranteed that because everything is defined, you're guaranteed you can compute with it without having to make assumptions, whereas with RxNorm, you need to make some of these assumptions. So we've been able to translate RxNorm into the SNOMED international model for the most part, and the keyword is for the most part. But again, there are a lot of details that need to be taken into account, and there's a lot of differences that pop up. I mean, when you look at two things carefully, which also offers an opportunity for quality assurance, because neither SNOMED nor RxNorm are perfect, and it's only when you triangulate that you find some of these errors that would have escaped even the detailed attention of the editors. If you want to explore RxNav, I invite you to go, and you can do this by yourself, to go to this URL here, and you can search. So SNOMED is integrated in RxNorm. So you can search a SNOMED CTID directly in RxNorm and see how it's represented in its RxNorm equivalent, if you wish. So that's what I would That's what I would invite you to do. If you do this, this is the RxNorm interface. And you can see that our friend that we started with, the amlodipine 10 milligram, atorvastatin 10 milligram oral tablet, it also exists in RxNorm. And that's the way it appears in the RxNorm graph. So we don't have the links, if you wish, among the boxes, but it really forms a graph. And you can see what the ingredients are. You can see the various levels that I was talking about. And of course, because RxNorm includes both the generic and the brand entities, you can see on the, it's probably the right over there, the right-hand side, you can see the branded equivalent for the medication that we've been talking about quite a bit. This is what I was referring to earlier when we talked about drug classes. And this is RxNav. And what you can see in the class view tab is we have the disposition, structure, and therapeutic classes. That's the SNOMED drug classes. But we also have ATC and a bunch of other classifications that we provide, that we link to, if you wish, as part of this browser for RxNorm drugs. And this is just an illustration of, yes, it is possible with a lot of hard work to translate RxNorm, making some of the assumptions, I mean, making explicit some of the things that were implicit. It's possible to translate, for the most part, the RxNorm content into the SNOMED messenger product model. And again, I'm showing you an example that works. I'm not showing you the many that don't. But in this case, it's the same concept that we started with, the atorvastatin amlodipine. And so what we do is that we take RxNorm, we convert it in OWL into the way you would say it in SNOMED, if you were expressing this with the SNOMED model. So we have RxNorm in OWL, if you wish. We have SNOMED in OWL, so that we get. So we can put them together, classify them together using the classifier. And then the classifier is going to tell us if we have the same definitions. The classifier is going to tell us, oh, this clinical drug in RxNorm is the equivalent, the equivalent of this SNOMED clinical drug, okay? And that's exactly what you see on this slide here. So what we're looking at is the SNOMED definition. And it tells us that, oh, there's this, the yellow here, it shows us that, oh, there's this RxNorm entity that is equivalent to it. And if we go see it, we find the definition for the RxNorm entity. And conversely, it says, oh, and by the way, the SNOMED clinical drug is equivalent to it. Okay, just showing you that it's possible. And in some cases, it works really well. In other cases, there are things that get in the way that need to be resolved. And Dion is going to tell you more about the things that get in the way.
So we'll return after the break. We're going to have Dion talk to us about Australian medication model and some experiments in interoperation. Then we're going to go into observables and talk about laboratory and pathology results. So go and get your cup of coffee and we'll see you back.
Yeah, so that's right. So for everybody who's online and watching this and isn't in the room, we'll be going away now and coming back in 20 minutes time.
So come back a little bit early.
Yeah. That's something that is that? Yeah, she.
Oh, yeah.
It's not. It's in ours. Okay. And then the guidance and.
Well, it's, it's, I think that probably. One way you get your.
I'll try to watch.
Yep.
So you're gonna get things. Okay?
Yeah.
You're gonna get, for example, if you pour in for a setting, you're gonna get two units here. Okay? The product and the substance. So there's a couple of things that you need to know. So you understand what's going on. But yeah, for the most part, you're gonna get all this. There's another thing we talked about that the arsenal is actually fueled by an API, and you can actually query the API and you can say, I have these art screens, give me the story equivalent, all the other way. If you start with the standard CPI, you can just say resolve that in art screen.
Okay, that will make it to the. Because I did want
So the master, the equivalency so if you find when, so which
then I can choose.
all right, so choose time. So if you take an ice screen that has the shell and equivalent, this add this house.
Good.
Presenting tomorrow.
Right.
have no idea.
We're gonna get.
Sync up with that.
Okay.
Is it gonna be a laptop or something?
If you start.
No, so I don't know.
And if you start from the clinical practice, as you know, it's no, you're gonna get the product. Okay? There's no need for any false coordination. Because the pre-coordinated exist. And so it's possible that you get nothing. No, but if there's no equivalent. I'm not sure. It's confidence. That electron specific and the single line that being inside the bottom examples of this. Yeah, you would not gonna get an equivalence, and if you want to have an equivalence knowledge, you're gonna need to build it yourself. It's not gonna be both coordination, it's just gonna be an expression. Well, or everything's called.
Yeah, you can technically.
Yeah.
Yeah.
It's an expression. Now, you know, we use the same template as for every other table. Okay.
And from Babylon.
So what's that?
Babylon's it's an international company. We mainly operate on medicine, but we also incorporate assets from around the world, and we're trying to then from the hospital to do some needs. So we're receiving a lot of personal.
But so the easiest is probably use data. Okay. Find RSP by ID, I guess, is the name of the resource. So SPI, the resource that we use. You're gonna say that the RSP that you're giving us is a 5 storm XCT and is a value No, you want some, so in this case, it's gonna be something. Are we giving this? Now I don't. My brain's fine. But I can double check. And in the worst case scenario, because the beauty of the API is that it is publicly available. And in order to do this, we will refrain from providing proprietary information. And so everything pointing to our external is fair game. So if you come with, the storage ID, you probably get it from somewhere, it's here. And therefore we have to resolve it into our external. The other way around is we're not sure. So we, in order to give it to you, need to make sure that you have a US license. That's how we come to control the membership of the US. And now I have we have one thing that's going to get the information. I believe that will return the spelling code as part of the get proprietary information. So what we ask you to do then is to pass an API key that
Yes.
that's the only way that.
Or if you're, and this is the demo browser. Yeah. And if you
It's not,
search for something, or is that something? No, that's from Jim's.
Jim's ECL.
Yeah.
You can
If
just-
you search for some like stuff,
make sure
yes, you
that
could just search for one.
security away things that when they allow.
I'd say we should be a lot of fishy, and it's there.
Yeah.
No, I can see.
Good, that's great. Yeah.
If you have, I can come to it, if you have a laptop.
Oh, my laptop has died. It was incredibly annoying.
Okay, so in this case, you might send me an email and I will reply.
Email and,
You have my contact?
I do because. of the
Okay,
presentation.
good.
Yes.
And I will be happy to send you the details. Okay, and if you have a conversation or anything, we'll do that.
Thank you so much for that.
Very good. Thanks. So far. Yes. Still a little too ambitious. That was good. It's a lot of information. Are we gonna test again?
Yeah.
So we'll see, we'll know exactly. How much I think I have to.
You get credits for where you get the prize, and
Yeah.
you get a drink, you get a reception.
Oh, yeah.
Oh. I have, I'm watching the QA and chat.
Oh, okay.
To see if there are questions, and so if there, but when I do the talk.
Yes, I can, I guess Jim or.
I'm logged into that.
Oh, if I can
Teams,
just use that,
maybe
then.
just put that out there.
Yeah, if I can just use that, that's fine.
Yeah.
It's only because
If
I
there
don't
are-
have my laptop.
Messages from my wife and just write whatever you want. Oh.
Okay. No problem. Yes. Yeah, it is.
The, I don't know, see here. You get. Done that on for a while.
Yeah. I don't see this in. I haven't been able to get time to do the post coordination example that I wanted to.
Yeah, but there will be, we probably want that time.
No. Well, it would look good because I was just thinking that looked at an example of in the UK, you can get a lot of tablets that are 10, 20, 30, 10, 30, 10, 20, 30, 40 days.
Yeah.
And in Australia, there's no 30.
Okay.
So if you
Or which, right?
and Olivier.
Okay.
So if you send the DNB code for that, and I can find the only thing I can do is find in DNB the parent that's in the international edition, and then send that to the Australian.
Yeah.
But of course, when you look at that, you won't find any, like you better take it all the way up to just end up in the product.
So there is no like modeling clinical drug. So a clinical drug would be the wrong level, but
yeah, there might be, yeah. But if you were to exchange the post-coordinated expression and classified age and were to look at that in shrink, it would be in between all of the other tablets in AMT, and then do this extra one in there, which would be the post-coordinated expression. So it would show you exactly where it belongs, which would be pretty cool.
yeah, that would be.
I'd be able to get a general example.
That's my
For the cable.
Anytime you think, Dion,
Watch out for the cable. There, it's
what you send that up to chirping?
uh, well, not only.
Yeah.
I've got the online, and then Dion will look after the questions. And this microphone is actually on. Yeah. And there is
So don't talk dirty or anything.
no. Okay, sorry, we'll just get started in a moment, particularly for the people online.
Dion, introduce yourself.
Yep.
We haven't had a chance yet.
Okay, so I will just unpause this. Great. Okay, it's a few people coming back in, so hopefully we haven't lost too many people, haven't scared away too many yet. So my name is Dion McMurtrie. How do I explain who I am? I work for CSIRO. I used to work for the Australian Digital Health Agency, and they were NETA before that. It was sort of one continuous organisation for, I think, about 12 years, where I was sort of the technical lead of the National Release Centre for Australia, and did obviously a lot of work on AMT for its initial version in 2008, I think, and then it was revised in 2014-ish or so. That's known as AMT v3. So I'll go through and explain some of the things that I've done here. And it's really an exploration similar to what Olivier has shown you of how we can do interoperability with between, say, AMT and an RX norm, or AMT and DMD, the UK drug extension, by using SNOMED as sort of the bridge in the middle. So this is the AMT concept model. I know that that's probably not really very readable, but I'll sort of explain what this is. And this is the V3 model created in about 2014. I think it started maybe 2012. So and it's very similar in many ways to DMD, for anyone who's familiar with that from the UK. So it's really got two sides. I'll use my pointer on here so that the people online can see that I'm not pointing at things. So there's this side here, which is really the generic side, and then there's the trade or branded side on the right-hand side. So, and then it's very much divided. The upper part, we have this concept here, which is really referring to a branded tablet. So for us, a brand of paracetamol is Panadol. So Panadol 500 milligram tablet would be this concept here. Below this line, it would be referring to a pack of that. So let's say a pack of 24 in a blister pack, for example, and there's lots of different examples. So that's the product and the packaging. And on the left-hand side, we've just got sort of generic abstractions of that that don't include the branding, and they get used for prescribing sort of use case, generic prescribing use cases that can happen at the pack level as well. So our clinicians, our GPs are not allowed to prescribe
specific branded medications unless there's some particular clinical reason. So they have to do that at that bottom left-hand corner. So the relevant piece for the international model and where the intersection is this section in the top corner. And the rest of these pieces are content that isn't in the international content. So looking at how these two things integrate, so the black boxes are a very simplified view of the international content and model, which again Olivier talked about before. The red ones are kind of where AMT bolts onto or sort of logically connects onto to that model. So you can see here some of the key differences though. Medicinal product in AMT is very similar to the idea of medicinal product in the international edition. And then you have this idea of a medicinal product unit of use, which is the sort of the 500 milligram paracetamol tablet idea, which becomes a subtype of medicinal product form. And then we've got our trade products. So Panadol or heroin or a particular branded version of that. You'll note that this particular concept here subsumes clinical drug. So one thing that's happening here is that AMT doesn't use the only semantics that the international content does. So AMT uses the some semantics, so it contains at least. The same way as the rest of the semantics of SNOMED CT works. So SNOMED CT works that way for everything. And it's sort of, people often get confused about this or as to how the prescribing works, right? Because if I prescribe, in a very simple example, 500 milligrams of paracetamol for that concept in AMT actually subsumes concepts that contain 500 milligrams of paracetamol and potentially other things as well. So it will have children and descendants that have more than just paracetamol in them. And you think, how can this be? That's not what the doctor's saying. Well, it's sort of similar, and I'll use Baker's example from the other day, which I found amusing, talking about other areas of SNOMED. So she was talking about someone going off and having a vasectomy. So male sterilization is the concept she was talking about. And so if male sterilization is the thing that's been said, there's descendants of that. One of them is vasectomy and another one is castration. So obviously they're quite violently different things. And just saying male sterilization doesn't imply the castration. So it's the same thing that happens in AMT. When a prescription is made at this generic level to say 500 milligrams of paracetamol, the clinician has said that, and they haven't said anything else. The omission of those other statements doesn't mean that they're ruling it out. It doesn't mean that they're ruling it in. And obviously then the clinical protocols will kick in. And I imagine that no one's going to necessarily go and grab some random descendant of that that's got other things, so just like you would hope that someone wouldn't get castrated like that. So that's probably one of the biggest reasons, and that's why the classification hierarchies work the way they do and how the integration works. There's quite a lot of other differences, and I'll get into some of those, and there's a list here, so I've got some examples that I'll go through rather than talking through this list here. So this example here is just going to walk through what the definitions of these two equivalent concepts look like in AMT and in the SNOMED International Drug Model. And the AMT, this is the way it's looked since 2014 or so. So if we look, one of the big differences you notice straight away here is that AMT just says tablet, which is all our regulator says. It doesn't say whether this is an oral tablet or not, or any other things about it. So that's what's said. The international model, though, all of the forms used in this at medicinal product form and below imply root. So there's always a root wrapped up into the definition of the form, and that's a bit of a barrier at the moment. What I did in this prototype was just very aggressively mapped AMT to these forms that include root. So I've actually mapped and forced into AMT that tablet means oral tablet. That's almost certainly incorrect in some places in AMT, but it was interesting for the exercise. And I wouldn't have got any subsumption at all if I hadn't have done that. Well, any meaningful beyond medicinal product. The next thing is this idea, which is this idea of unit of presentation. And AMT has a similar concept or a similar notion, which is this idea of unit of use. And it's saying something slightly different here in that this AMT is saying that the size of this is one tablet. This is a very controversial and poorly understood feature in AMT that would probably may actually be trying to get rid of, because it just creates a problem. But I think it correlates somewhat to has unit of presentation. Not entirely though, unfortunately. There's the uses of these don't line up. This is a very simple example where they do, but there's plenty of cases where they don't, and where they arbitrarily differ. Unfortunately, you don't get subsumption. This is obviously where strength is being said. And so what I've done here, and in the previous example actually as well, is I've added into the version of AMT that I've created, the prototype version, a number of description logic axioms that are equivalent class axioms that have an expression on the left and the right hand side. So there's no concept, no pre-coordinated concept on either side, which basically says the way that AMT says 10 milligrams per each, which is basically AMT saying there's 10 milligrams per thing in this thing, is the same as the international, or is equivalent to the international's modeling with these 4 different attributes and 10 milligrams per tablet. Sorry.
I want to mention just briefly that about concrete domains, and
oh, yes, sure.
I suspect many people may not be aware of it.
Right. So what's going on in this diagram as well is that you can see the different looking things. So we've got these purple boxes, which are lavender boxes, perhaps, which are fully defined concepts. And then we've got these sort of yellow boxes, which are representative of attributes. And that in this case, this blue box is a primitive concept that is the target of this relationship. And that's making part of this is kind of a rendering of the axiom. It's part of the definition of this concept, that it has a particular boss basis of strength substance that is the value is that concept, which is an object property in the AL world. And then you see these other, I don't know how to say what that color is, tan colored boxes. This one, it says strength is similar over here with these has presentation strength denominator and numerator values. And you can see they've got these green boxes, which are equal to 1, equal to 10. These are concrete domains or data type properties in the OWL world. And so the value of them isn't a concept value. The value of them is a concrete value, a scalar value, if you like. So that's the difference, and those are combined together to form the axiom that defines what these concepts mean.
Yeah, Dion's team in Australia sort of led the way in terms of implementing concrete domains, with the first use case being drug dosing and so forth, which are now part of the concept of.
Yep. So axioms created to merge those things together. So instead of what Olivier was saying he did before, where he created axioms that defined RX norm concepts using the international model, so looking like the right-hand side, instead AMT already had a whole lot of axioms that defined exactly what these concepts mean anyway. So all I had to do was tell the classifier that the way AMT says this piece is equivalent to the way that the international says this piece. And then it can determine that these two things are actually equivalent to each other. So essentially that's what I did. And there's other things, like you can see here, we've got has Australian boss and has boss. So has Australian boss are declared as being a sub property of has boss, as an example, sort of like a refinement. There was a whole lot of things that prevent subsumption, though, unfortunately. Things like unit of presentation, where that unit of presentation value, as I said before, isn't actually consistent between AMT and Snowman International. I did it with DM&D as well, and it's not consistent there either. So I tend to suspect that's actually it has some sort of business meaning, and it's a meaningful thing, but it's not perhaps defining of the concepts, because it varies across jurisdictions that are really referring to exactly the same physical thing. And there's a number of other issues, like the strength denominator units. I think I've got an example of that. So I might just go through and we can show some of these and make sure, and I can cover off what they look like. So, and then there's some other issues as well where this assumption is correct. The necessary normal form calculation, which is what I mean by NNF, it passes through, unfortunately, only the stated form. So this particular example here, the thing in the necessary normal form, which is what ECL gets to execute across, ends up looking like the left-hand side. AMT concepts look like that, and international concepts look like the right-hand side. And so the ECL doesn't actually work very well across those two things, even though they're equivalent. And I think this is just an omission in the ECL or the necessary normal form calculation rules, which I think we can address.
I have a. Is this on? Yeah, I have a question. So the Snowman model is built according to the IDMP suite of standards. So when countries are implementing IDMP, will these issues, will these be resolved, do you think?
So yeah, it's interesting because IDMP has an overlapping but different set of use cases. And so really part of the question is, does, particularly at SNOMED International's content, maybe the drug extensions do need to go to this, but does the international content need to be as specific as it is matching a particular thing in IDMP, and which, may prevent it from actually subsuming as much as it could across the various national drug extensions. So does it need to be as specific as it is to still achieve the use cases it's there to achieve? And unfortunately, that what I've gone through with DM&D and AMT and the international drug model is that the use cases are really not very well defined. The requirements are not very clear at all. So unfortunately, we've got a model sort of void of that. So it's very hard to say whether you could make these changes that would improve the subsumption or not, because you don't know whether the use cases are going to get dropped or not. So yes, I think that there's some things we can do with the necessary normal form calculation rules. It's basically determining that because these things are equivalent, they're redundant, and therefore not including them in the necessary normal form. And I think something that's more specific makes something less specific redundant, but something that's equivalent but not more specific is not actually redundant. In fact, it's also necessarily true, so it should probably be in the necessary normal form. So there's some things we can do to fix that. But as a result, unlike the DL queries that we had in OWL a while ago, you still have quite a lot more challenges when you're trying to execute the ECL that matches the international model against AMT if it's using its model, and yet they're still logically equivalent and classify correctly because of the presence of the other equivalence axioms that I've included, which is how the hierarchy has been calculated. So here's just some examples. I'm sort of conscious of time that will show you the sorts of things that are problematic. So in this example here, you can see that the denominator unit here for this essentially paracetamol, acetaminophen, product is capsule on this side. So this is saying 500 milligrams per capsule, and this over here is saying 500 milligrams per tablet. To the classifier, 500 milligrams per capsule and 500 milligrams per tablet are two unequal things. They're not the same. But clearly, you know, to a human, these are 500 milligrams of paracetamol things. And the over precision of the capsuleness and the tablet is actually hindering here, not helping. So, and it's different actually to what AMT does, because AMT doesn't say the tablet or the capsule bit, and neither does DMD actually. So here's another example, and maybe really hard to read. I'm sorry, but for the room, people in the room, people online can probably see it. You can see on the left-hand side, these are fentanyl products. So we've got on this side, we've got and the upper part is the international concept. So we've got a fentanyl buccal tablet. And below that in AMT, we've got the equivalent sort of concept, 200 microgram fentanyl sublingual tablet. There is no buccal tablet. They're being quite specific, and they're not lining up to each other. And you can see here on the right-hand side, we've got you know, again, specific forms for you know, buccal lozenge. However, I think that the interesting thing on this, for this example, is that we've got AMT and DMD as similar rules, consistently uses a particular unit for a given ingredient in a certain form. So in this case, it's you know, fentanyl is always going to be in micrograms. So that means that this one on the left is 200 micrograms or 1200 micrograms in the definition, in the modeling definition, which means it's the classifier doesn't need to use any unit conversion to see those. In fact, the classifier doesn't know about unit conversion. And it also is useful for ECL. So I can say, show me all the products with more than 100 micrograms of fentanyl. But the international example above here actually has 1.2 milligrams. In the description, which is fine, but in the modeling, it's using milligrams. And again, the classifier and ECL particularly, if I say, show me all the things with more than 100 micrograms, I'd actually also have to write that in terms of milligrams as well, and join those together to get the right answer. So that's also a bit of a problem. And it causes a loss of classification. So AMT is not going to classify as equivalent to that, because AMT is using micrograms and the international edition is using milligrams. That is surmountable using some axioms that will say that, you know, 1200 milligrams is 1.2 micrograms. Oh, the other way around, sorry. But of course, that's not going to help you with ECL, and that's going to still be a barrier with ECL. So that solution doesn't actually achieve that much. Here's another interesting example. So this is sort of got to do with precision. So you can see AMT, again, we've got a difference in the units. So we've got micrograms on one side and milligrams on the other, but that's sort of less interesting in a way than the precision. You can see here, we've got 999.34 versus 999.300 micrograms. So again, these things are the same thing, but they don't classify as the same thing because of a difference in precision in this case, as well as the difference in unit. So that's also a problem. So what I did to generate this was I've done this essentially the same thing with AMT. So I've done as I described with AMT, created these axioms to be able to join its description logic up with Snowman International description logic so they can classify together. I also did the same thing with DMD. I actually had to write the axioms for DMD because DMD doesn't have an existing sort of logical form that's sufficient for that. Classified them all together, and then looked at what sort of overlap do we have between the total concepts subsumed. In this case, this is on the left-hand side, this is the medicinal product level. So the rings represent, you know, the number of products, the number of concepts being subsumed by AMT's medicinal product concepts, DMD's VTM concepts, which are the same sort of idea, and the international's medicinal product concepts. And you can see it's really high sort of correlation, and they're all kind of a bit of a difference there between AMT and DMD, but they all sort of stick together. The one on the right-hand side is that level, that clinical drug level. So the equivalent things are medicinal product unit of use in AMT, VMP in DMD, and clinical drug. And you can sort of see that's where the intersection's lost.
Does everybody know what DMD is? DM plus D is?
Yeah, DMD is the UK's drug extension, essentially, like AMT's Australia's. So, and this is a feature of the problems I was just talking about. The reason the subsumption doesn't happen is due to a whole range of these kinds of issues. I've actually cheated in lots of ways here. There's another distinction, for example, where the international content has actually 8 different properties for expressing strengths, 4 of them for presentation strength and 4 of them for concentration strength. Some products are represented using one or the other. Both DMD and AMT only have one set of products, so they don't make that distinction. But what I've done to work around that is I used property axioms to declare the concentration and the presentation strength properties in the international edition to be equal to each other, which basically removed the distinction. And I determined that was safe to do because then I reclassified the international edition and there were no changes. So that distinction being made internationally is sort of a barrier to connecting AMT and DMD up, but it doesn't actually change anything about the international content. Going on, and I realize I'm running very low on time, so I may not be able to run some demos, but I can talk through what is possible. So Jim's was saying, well, what if you've got someone who's got an RX norm coded drug, and then they're in Australia? How do you find the equivalent? How do you get across? And really, there's kind of 2 ways I can imagine trying to do this. One is to go up and find a common ancestor in the international edition that is for RX norm, and then you take that international edition concept and you go and look in AMT and see where that is and what you can find. The other approach is to use ECL, so you can get the definition of the concept from the extension from RX norm, and then you can execute that effectively as ECL in the AMT extension and see what you find effectively. So this is an example using paracetamol oral capsule. So effectively what this ECL is saying, the bit at the top here, is saying that we're going to find all of the ancestors of paracetamol 500 milligram capsule, so that which is a clinical drug concept from the international edition, and we're going to find the ancestors that are in the core module, the international edition, and we're going to then take away all of the ancestors of those ancestors. So finding the leafmost thing, effectively the lowest thing in the hierarchy that subsumes this concept that's in the international edition, and you get this one concept. And then, of course, unfortunately, there are barriers that prevent it from subsuming anything in AMT, even in, sadly, this quite trivial example. So the alternative is to take the ECL approach, which essentially is saying, well, this is the definition of 500 milligram paracetamol tablet or capsule in the international edition. And that matches obviously that concept in the international edition perfectly, and does the same thing in AMT as well, because that concept's still present from the international edition. This can actually be simplified, and I'll try and sort of show what's actually happened here. You can actually remove this kind of idea of the strength denominator unit of capsule and move to saying, well, it's just some type of unit of presentation, which is the parent of all of those things. And that works perfectly fine. And then you can actually remove a bunch of other things as well, because we've now here got the presentation strength denominator value of 1. And if we move here, we're actually saying that, in fact, this one thing, part of the definition actually doesn't change any of the things that you get back from this bit of ECL. But you're still not going to match AMT, unfortunately. So if you, and that's because of the NNF, sorry, I should mention that's because of what I mentioned before about the necessary normal form, not taking the equivalent things and considering them to be redundant, unfortunately. So this is what the equivalent thing looks like, the bit of ECL looks like for AMT. And you can see here that it's not greatly dissimilar. It's saying that, it's an active ingredient of paracetamol with a BOS of paracetamol and a strength of 500. In this case, it's a composite unit saying milligrams per thing. I've also added in here the thing at the bottom, which is because AMT uses that sort of some at least containing semantics, you can, and your hierarchy can only work one way, that way or the other way. You can with ECL say, and it doesn't actually contain anything else, which is that last statement in there, if that's what you want to query out. So yeah, and this works, but it doesn't work for things like if you have a 300 milligram paracetamol capsule, because Australia doesn't have them apparently. We've only got 500. So then look, but I guess the good news for all of this, even though it's quite problematic at the clinical drug level, this interoperation, at the level above in medicinal product, as you saw, the intersections are quite good. And in fact, quite a lot of the value that we need to derive from this comes from that level anyway. So we can get, so I'll get through into looking at some of these examples. So because of these changes that I've made, this is something you couldn't do in AMT before, because it wasn't connected to the international model. You couldn't say, look, find me all the things that are antibacterial agents, but you can now do that because it's been classified with the international edition. This constraint in the bottom here is saying where the module is the AMT module. So it's saying, show me all the AMT things that are antibacterial agents, and that's come from up here, this therapeutic role that's being played. It's interesting, actually, I found antibiotic as well, which is in the international edition is primitive, and it doesn't actually subsume anything, but there is antibacterial agent, which works for this. And then there's, immunosuppressants is another example. So again, this is saying, find me all things that are pharmaceutical products that have an active ingredient that's some kind of immunosuppressant. And again, find me the things from AMT, and you get a list. So that works really well, and all of these examples work. I know I'm actually over time, but this is interesting as well. So I'll very quickly cover this. So Olivier sent me a list of drugs to use as an examples to say, well, someone may come with one of these. How do we find the correlation in Australia? And you can see the first one is an atorvastatin 40 milligram oral tablet. That's perfect. That works. It matches. Interestingly, I was just saying to Daniel in the break that DMD has a 30 milligram tablet. AMT doesn't have the 30 milligram tablet. So, but then when you get down into this next product, this actually doesn't exist in Australia. And this is an eye solution. There is and I've included the link there to our regulator. You only find that ingredient in tablets, and I've included a product that is probably the thing that you would use in Australia instead, but that ingredient doesn't come in eye solutions. Same thing again for this next product. In fact, that ingredient doesn't exist in any products that are registered for use in Australia, at least at the moment. Prednisone, that worked fine. And then the one down the bottom is again interesting in that this is a multi-ingredient tablet that Australia, there is those ingredients exist in separate tablets, but not in one tablet, and actually not in the strengths that are provided there. So even just simple things jurisdictionally, they don't line up, and that's where that getting that clinical drug level to work is across all of the content is really tricky, because they often just don't line up.
You want to sum up, Dion, with a statement of where Australia plans to go with their drug model and interoperation with the rest of
Yep. So I think essentially AMT and DM&D, and I think RX Norm as well, all suffer effectively the same problems trying to integrate to the international model and the international content. That there's very similar barriers. So effectively, the plan for the UK is to adopt the international drug model and international content as much as they can. But unfortunately, because of a number of barriers, it'll probably drop off pretty quickly after medicinal product form and clinical drug work. They won't be a lot better than what I've represented here for a lot of the reasons we've talked about. AMT, we're going to do basically the same thing over the next little while. We're planning to and the plan was always with AMT to integrate to the substance, international substances and pharmaceutical products. Hadn't done that before because there were issues with the subsumptions of the substance hierarchy, and also the drug model was changing, so we didn't do that. Now we're probably in a position where we could do that, because it has become stable enough to do that, and as a result we'll get the sorts of benefits that we talked about here. The drug class things that Olivier talked about before will come into AMT, which we've had people begging us for years anyway. So that's where most of the value will come from. To integrate lower is probably way too hard for both AMT and DM&D. It's just too much change, and really probably wouldn't deliver any extra value or not much extra benefit. So the good news is the benefit all comes from the level that's actually pretty easy.
There is a comment from Robert Wynn from the NLM. RX Norm has the same challenge when implementing dose forms and templates. The Snowman manufactured dose forms based on EDQM are more granular. Also, unit of presentation do not exist in RX Norm. Analysis on both sides necessary before configuring our templates. From source EDQM Snowman dose form mapping could be helpful, but may not guarantee dose forms on clinical drugs are one-to-one.
Yeah. So I think the bottom line is that there are changes that could be made in the international model and content that would allow it to subsume more by it becoming less specific. Some of these changes don't really actually make a material difference, like the strength thing I mentioned before. That's a distinction which doesn't change the definition of the concepts. But others are maybe more problematic.
Shall we move on?
Sure.
There. See the. You know how a Windows machine works? Yes. So there, I will see. I'll try to be quick because we have a reception to go to afterwards, so I don't want to stand between you and your drinks. So I'm Daniel Karlsson. I work at the National Board of Health in Sweden, which is the Swedish National Release Center. I've been working with the Observables project for a while now. I'm the current chair of the project group, and I will start by presenting an overview of the Observables model, so that would be a bit easier for you to get into at least slightly easier to get into the examples that we will see later on. And I should also acknowledge all the people who have been involved in the Observables project, some of which are here right now, going through the work in that project group from the conception of the observables model until where we are today. So see, can I use this for pointing? Yeah, there. Yeah. So the observables model is based on an assumption that there are two main aspects of an observable, and one is what entity is being observed. What is the thing that we're trying to find out information about? And the other part is how do we go about to get that information about that thing? And I'm taking a very, very simple example. We have core body temperature, and it's in hyacinth. It's a property of the body internal organs or the hypothalamus. There are perhaps some definitions to consider there, but it's something in the body. The property that is measured is temperature. So it's a temperature of the internal parts of the body. When we look, and this is a yellow, I guess you might have guessed that, but that's yellow attributes that we see there. On the other side of the model, that we look into how we measure this property of the body. There might be a direct site that is a site where we actually does the measurement, and in this case, we take one of these tympanic membrane measurement devices and put them into our ear canal and press the button, and we get a number. And that is that part of the model that allows us to model that is like procedure part of the model, how this measurement is being performed. So if you're taking need to take anything from this very short introduction into the observables model, is that it has two parts. It's a what part and a how part. And there are different attributes in this model which are used to in authoring of these observable concepts. So there are now 22 attributes in the current concept model. If you go into the machine readable concept model, which Jim talked about before, if you go into the browser, you could actually, there's a button there, you could go into a machine readable concept model browser, and you could look at all these fancy attributes. The model is now fairly stable. It has evolved over quite a long time now, but as we will see later, it was applied to mainly laboratory medicine in the previous work between Snowman International and Regensreef on representing loin content. So the model is fairly stable, but there are application to new domains. So we did nutrition and nutritional intake, and we didn't make major changes, but we adjusted it through attributes, and we wrote new guidance for how to apply the model, and that is likely to happen over the years to come, where we make more application of this model. We identified 4 different patterns where specific attributes are identified, and this is not for types or for hierarchies or anything. It's just 4 sets of patterns, and there are these could be used in common, and there are some common aspects of these. So the 4 of these panels are quality observables. That is anything that is related to quantities. That is like what we normally do to measure stuff. This is a vast majority of use cases. And if you look at laboratory medicine, it's almost everything. Process observable, that is anything that is, bless you, anything related to time. So we have things like things that evolve over time, so like excretion. Function observables is capacity to perform stuff. Disposition observables, that is things that are not always realized. Predispositions, and typical example is susceptibility. I will just give some more examples in detail. So we have, I see on top of the screen here, we have a number of examples. We have a SNOMED code, we have 2 LOIN codes, we have an MPU code. An MPU is terminology used in a few Scandinavian countries and Czech Republic, for your knowledge, but it's comparable to LOINC. So you see some examples there. As you see, there is a property in these 2 examples from LOINC. It's a mass per volume, that is a mass concentration. It's a moles per volume, that is a substance concentration. MPU has only substance concentration. And we could represent that as, and this is glucose in serum or plasma, or glucose in plasma. So we could say that it's, for example, it's inheres in plasma. Property is quantity concentration or mass concentration or substance concentration, depending on what level of granularity you want to specify a concept on. And there is a direct site, which is like, it could be a plasma specimen, it could be a serum specimen, could be a generic specimen code for a cellular blood specimen. I think they saw one of the previous slides. A process observable example, it's just different that it's based around physiological processes. So here the property is mass rate, and like I have like albumin excretion mass over time in 24-hour urine is an example. Characterizes excretion. That's the process that is being made observations about. Process output is albumin, process duration 24 hours. That's common for all these, the SNOMED, the LOINC, and the MPU code. And process agent, we could define that as kidney structure, although that is kind of a given thing, or it could be different specificity of what part of the kidney is involved and so on. And you have like a direct side, the urine specimen, for example. Function observable, I don't think there is anything in laboratory, but just give an example. So ability to walk, it's a property of the person. The property is ability, and that has realization. That is, the realization of this ability is the walking. So that is how we would represent. This is not currently implemented in the international release. So last but not least, disposition observable, susceptibility. I have 2 examples, amoxicillin, and the susceptibility is a property of the bacteria. It's not it's the bacteria that has the disposition to be inhibited or killed off by the drug, and that we use as a towards attribute to specify what is the triggering factor of this disposition, and property is susceptibility. So this is some examples. Now I'm going to, this was a very quick introduction into the observables model. I will talk a little bit about the the terminology, because we will look at the examples, we'll look at some test codes example that are represented using SNOMED CT. But we also know that I had a time there, that we have a lot of coding that needs to happen in addition to the test code. So I will talk a little bit about that, and specifically I will discuss some of the results of the EU Cross eHealth project, which is a project that has set as its goal to develop a common model for sharing of laboratory result reports in Europe. Well, yeah. And then we'll look at some examples afterwards. So the Cross eHealth has developed an information model for which is based on like the effort. What you see on the side here, I don't expect you to read this, but this is the logical information model that has been developed by Cross eHealth, and it's based on many other experiences. This is a fairly mature area. But we found that in this information model, we found a lot of areas where we need coding. So like specimens, specimen containers, study types, devices, kits, methods, results, both like ordinal scale, nominal scale results, and interpretation codes, and et cetera, et cetera. So what we did was that we collected like lists of coded elements from different countries in Europe. So you see some examples there. We created pivot tables to see what are the most commonly. So like it seems like those on the top here are used in multiple countries in Europe. Not everything was SNOMED coded, but we spent some time in trying to encode it with SNOMED, but where SNOMED value sets were available, those were used. And we used SNOMED for a lot of these code systems. So the proposal, at least tentatively, we have SNOMED for specimens, methods, etc., etc. So now I will run into the examples, and I have them on my phone here so that I won't make there. And
Daniel is going to be doing some browsing, which you can also do. We have set up the Nebraska website, and Rory put it out for us. It's demo, DEMO dash browser, BROWSER dot
I'll manage
SNOMEDtools.org. And there you'll see a browser site that has the Nebraska content, which is what you're going to use, right, Daniel?
Yes. So yeah, thank you. So what we're going to look at is the results of there was a previous collaboration between LOINC and SNOMED International, where a set of SNOMED representations of LOINC terms were developed and put into something that was called an expression ref set or something. This was fairly hard to consume, so we'll be looking into this, that it has been imported into a normal SNOMED browser. So that's what we're going to look at today. And the work, there was some 20,000 LOINC terms that were represented in SNOMED format, and that work was done by SNOMED International. I would mention Farzaneh Ashrafi and Suzanne Santamaria, who did most of the hard work of doing that, and also the discussions in the Observables project group, where like Bupe many of you participated. So, but let's jump into the example, and we'll start with a fairly simple one: blood glucose. And blood glucose, we've identified in the this cross-EF project that there is a slight variance there. If you look into LOINC, there are quite a few blood glucose codes, and there is a variance in Europe in lab cultures, even within countries. There are different codes used in like Eastern Germany and former Eastern Germany, former Western Germany, and so on. So there is a challenge here. We took tried to identify the top lists from a number of different European countries, and in the top 1,000 list there were 2 blood glucose codes, so 2 different ones. Let's see. Let's jump into the. How come? Yeah. What did I do wrong? Don't do it again. So I will use the ECL builder as we've seen before. I'm trying to click there. See, and I start at the top. So we didn't manage to get all of these observables fully defined when the previous LOINC SNOMED work was done, but pretty close to 100%. So, but we start with observable entity. You just have to type the beginning of words and it will eventually find, and then we'll add the refinements. And first to the left here, you see if there is any hierarchy of the attributes. You could use this descendant or self of or any other operator there, but that has not at least yet been applied for the observables model. So self is I find this slightly difficult to use Macintosh. So let's start with the property. There. And so we want to cast a wide net here, at least first. So I will seek to find both mass concentration and substance concentration. And there I happen to know that in the SNOMED CT hierarchy of properties, there is a quantity concentration that subsumes both. There. Now I'm going to add. So what is this property a property of? So we're looking for blood glucose, and the way that it was represented, we used the concept blood material to represent any material that is related. So that include plasma, serum, etc. So I'm the attribute that we're after here is inheres in, and that means that the property inheres in blood material. Why is this not?
Sometimes if you type the whole word.
Yeah.
And leave a space after.
so the question was, why not just blood? And that has to, so that's the way the hierarchy, so serum is not a kind of blood. So that was the way this has been modeled. But why is this not? Ah, there. Yeah, now this, what? Cancel. I don't know what happened there. Did it find a phone number or? Yeah, okay. So we should try calling. Yeah. So and next one, any ideas? I don't know if you remember, I almost don't, but we were actually looking for blood glucose. So what attribute do we use to specify what is the thing in blood that we want to see the quantum concentration of? It's called component, and this is actually the same. We use the same definition of component that is used by Loink, for example. And let's hope this is more responsive this time. Let's see, how are we? We are not very good on time. And there is one thing, and I will tell you instead of showing you. There is a feature, a very nifty feature of expression constraint language, which allows you to set cardinalities of the attributes. And one of the things that you would find in when searching for these, there will be like blood glucose 15 minutes post challenge and stuff like that, and that we're not interested in here. So we will set this to why, so how this is dangerous. Yeah, so I will just type could you type a star there? Yeah, it's not, the keyboard is also fishy. Is it? Yeah, I don't know, where is the star? Ah, there. So I will type okay there, and now I will, so this is this is so it does a lot of smart things, but never the ones that you wanted to do. I will, is this the, so I type 0.0, that means I don't want any preconditions here. Skip those. And now I type execute.
So for your other examples, we've got the UCL.
Yeah, yeah. So there you see, and this is kind of interesting. You see there's different, it's mass per volume, it's moles per volume, and interestingly, someone has sneaked MPU codes into the Nebraska lexicon. So we actually were able to get some international interoperability here as an outcome of this this simple ECL exercise. So let's see where we are with the timer. I think if I could have like just a minute for the next slide.
Explain to Scott, here's the one.
Yeah. Yeah, so one of the issues is that what we also see, like there are some options for using, for example, loin codes. So there you see two examples: bacteria identified in isolate and bacteria identified in isolate by culture. So there are two different loin codes, one with and one without a method. And like if you have, for example, a FHIR model or any information model, you have the possibility of specifying a code. This is the observation resource from FHIR, and you have the method. And let's say that you're using SNOMED. And if you look into the example, you would see that you could actually use to construct an ECL query that allows you to like work across like terminology and information model. So you could add the technique from the methods slot in the FHIR model to the ECL expression for finding the code to see if maybe there is someone who's used the more specific line code. So I plan to show one of the examples where you actually use so like you could very easily query for what have there been a test for benzodiazepines.
Document and direct them, they can.
Yeah,
they can do the exercises themselves.
Yeah, you could do the exercises themselves. I don't know where the document is right now, so I'll just skip that. You'll have to trust me. It's easy to do. Yeah. Just trust me on the.
I'm sure Daniel will be running out and getting an apple really soon. But this is the document that Jim is referring to, and it's got all of the ECL that we've shown and a lot of the ECL we haven't shown because we don't have the time, including a whole heap of examples that show how this works for AMT, and you can run those yourself. So the examples that were just being run is demobrowser.snowmedtools.org. For other technical reasons, it wasn't possible to get the RX norm content actually loaded into any browser. It's in OWL only. However, the AMT content, if you go to the shrimp browser, which is ontoserver.csiro.au/shrimp, and if you go and select, what have I done? If you select the code system, SNOMED CT, and in here you'll find when you drop down this box to see what versions there are, there's actually an experimental AU version and this long line experimental GB version, and they're where you can run ECL against these. So this is the ECL browser in Shrimp, and you can do basically the same thing. Cool.
Anyway, the last few pages have Daniel's lab example, okay? And they'll also have the examples that Scott is about to talk about.
You're going to be okay with that?
It's singing to me. The Mac is so happy to find a Mac user coming here. Well, hi folks, I'm Scott Campbell. I get to talk about cancer and cancer synoptic reporting and what we've done in the observables model. I'm not going to spend as much time on the ECL queries because you can look them up. We've gone through the principles of what they are, and you can execute the queries. I can say that the queries that are about synoptic reporting, you should execute in the international browser because this is all now published broadly for international use. So we talk about cancer synoptic reporting. Well, what does cancer synoptic reporting mean? These are all the different ways that the colleges of pathology in the UK, Australia, the United States, the International Collaboration of Cancer Reporting, PALCA, basically what it is, these are highly concordant protocols. These are protocols clinically that a pathologist is required to report about a resected tumor. What was the nature of the tumor? What was its histology type? Where was the tumor located? What were its invasive properties? And anything that is considered minimal data set for both diagnoses and prognoses, so patient treatment and care. And the nice thing is this content is highly concordant with the minor exception that our friends in the United Kingdom don't spell English correctly. So we do have to accommodate for that. But other than that, We started this project in 2014. There will be more details tomorrow if you care to see how to implement this, and I'll do real queries that are in fact ECL queries done in a functional operation SQL data set, actually doing graph theory for real, pulling real cases forward. So based on 5 years of tumor data that we've collected and continue to collect in real time at our hospital. So this began as a project with the College of American Pathologists. I won't bore you to tears, but it just became a thing of the world. We are the world. And I think there was a song written about that and we still sing it. And 2020, the content that Jim Campbell and I developed in our extension, we donated to the international community. And then SNOMED, I do think Jim Case was drinking or something because he actually let me into the authoring platform, not unsupervised, but into the authoring platform. And we are authoring these concepts now, and they're being regularly released on a monthly basis as we continue the content. About 80% of solid tumor content is now represented. So what does that have to do with observables? Well, you can't see that very well. So we leverage the observable entities model that Daniel was talking about, and there are a handful of properties that are extensively used that if you are going to do ECL queries or ECL-like queries against your data, it's important to understand the attributes we use. Property, the what we're measuring, the adheres in, I love this, the carrier of the property that we're measuring. I'll let you ask Daniel for explanations. The inherent location, that actual place that the carrier of the property is. Again, he can do that. Characterizes, in other words, that's a process that we may be looking at, such as invasion. Process extends to, matter of fact, the tumor directly invades to something, and that would be the process extends to and component. For example, the thing we're measuring indirectly, estrogen receptor would be an example. So I'll just kind of, again, boy, it's so much better on the slides and when you're on Zoom, but now we're in person again. And so we have to realize that we need much bigger screens. So this is an example of histologic type. It is published. So it is a measurement that is really defined as taking the property of histologic type. So that's a new property that we defined that adheres in a primary malignant neoplasm that is located in some structure, in this case, the breast structure. So is a primary malignant neoplasm of the breast. I will now tell you the histology type, adenocarcinoma. We do put in the scale type. It is nominal because we're going to give you a word string, adenocarcinoma, ductal in situ, mucinous carcinoma, and it's a single point in time. We've also modeled direct invasion, actually, and indirect invasion. That would be metastatic. And in this case, we're actually measuring a property. And there's two ways to actually measure invasion. One is I'm measuring the presence of a neoplasm that is in a place it's not supposed to be. Not that a neoplasm should ever be anywhere, but it went to somebody else, somewhere else it's not supposed to be. So basically we're measuring the presence of a malignant neoplasm, right, that exists in, let's say, the breast or the prostate. But now we're going to measure the process of direct local invasion. So now this is a continuous invasion or a continuous growth process of a tumor. And that process extends to someplace. Let's say it extends to the periprosthetic tissue. Well, as a GU pathologist would say, is there extraprosthetic extension? Yes or no? Well, now we can say, yes, there is. The answer, of course, is an ordinal value. It's yes or it's no, right? That's essentially bad or not quite so bad. The other way to do this, of course, is anatomic site that is directly invaded by. In that case, the answer is some structure. So the adenocarcinoma of the colon directly extends to the subcolonic or the submucosa of the colon. Okay. Histologic grade, again, similar. This time we're measuring a property of histologic grade. That's a new thing. But we also add in a property called technique. Unfortunately, technique matters. So if we're measuring the tumor grade within the breast tissue, we're probably going to use the Nottingham score. However, if we're doing it in the colon, in the US, we would be using the AJCC content, which is a forced tiered system for grading. But if we left the US and go to the Netherlands, they're using the World Health Organization 5th edition. So we have to actually state what grading system is being used. For the prostate, it would be the Gleason's grading system, for example. So technique matters. So what I really wanted to talk about here, and I'll talk about it in theory. It's not in theory, it's in practice, but I don't think we have time to actually demonstrate it. So a real case would be, I want to find, and this could be for, I'm trying to identify patients who are eligible for new therapy. I may be trying to find patients who have exhibited these characteristics of a tumor because I'm a researcher and I want to get biospecimens to conduct some specific research with. So these are real questions. So I may want to look at all the primary malignant neoplasms. And unfortunately, you probably have all experienced this. A researcher never really knows the question they're asking. They do, but they don't speak terminology. So usually we have to help them. I want to get all adenocarcinomas of the gastrointestinal tract. And they may even try to say, and here's the code, and they may give me a digestive system answer. Well, guess what? The digestive system brings in everything that comes in and the whole way on until it goes out. And that's really great if we want to talk about another kind of process. And we can continue to shrink that until we get to the concept of large intestine, which actually has the colon, the rectum, and the thing that, you know, is the final ending point, but it also includes the appendix. So we actually have to exclude the appendix when we do that. So there you go. So without just too much hand waving, and I'll show this tomorrow, but we have a data set in Nebraska where we have been collecting these encoded synoptic reports for colon, breast, and melanoma for 5 years. And we just put it into a new database structure that will be easier for people to use. But this morning I interrogated the data set doing exactly this. How many cases of primary of tissue, and these were also tissue that could be consented for research. How many cases of primary tumors of the large intestine do we have? Well, we had 427. Then I said, great, how many of those actually had tumor invasion out to the submucosa? Oh, we had another, I think it was, well, actually I joined it with, and had lymphatic involvement. So I wanted to know how many colorectal cancer cases have we seen in the last 5 years that were only adenocarcinoma that had direct extension to the submucosa and only the submucosa, but also had lymphatic involvement, and how many lymph nodes were involved. That returned 72 unique cases like that. So it's now join that with the patient phenotype: white male, heavy drinker, black female, obese and a heavy drinker, whatever those things that you're trying to study, right? In whether you're doing a population study or you're doing an interventional study retrospectively, these are the types of data that we've been wanting, that our pathologists have unfortunately not had necessarily the tools to record and expose these data in a way that we can compute. So it's always been lost to what I call pathology poetry and lovely descriptions with the most beautiful pink and purple thing they've ever seen that is somehow bad. So trust me, it works. Anyway, I won't go into it. There are a set of queries that will walk you through how we use the inherent location, if you would, aspect attribute to narrow in the search, right? And we can, because we have, I think 58 or so histologic type of primary malignant neoplasm of organ X concepts that are identified. So now I can go into very long parts of my digestive system or very focused parts of my digestive system, if you would. We can also then say, well, how far did this tumor grow? We can do that very constrained. We can, in the prostate, for example, if I look for direct invasion within a prostate tumor, and I only talk about direct invasion, I will actually get a return of spermatic cord, periprosthetic tissue, seminal vesicle, and lymphovascular and perineural. Well, lymphovascular and perineural invasion are not exactly what I wanted. I wanted something extracorporeal, if you would, to the body or the capsule of the prostate. So there's an example in there how to negate that and get something very, very specific. So I hope you enjoy it. If this is of interest to you and you are looking for something very boring to do tomorrow, somewhere between, I think, 10 in the morning till noon, we'll be talking about cancer. And then primarily after that, we'll look at some gross specimens and then hope you can eat your lunch afterwards. Just kidding about the gross specimens. But I do hope you can eat your lunch afterwards.
So Scott, would
Yes.
you flip over to the Word document and just show them your queries?
Okay. Oops, word. All righty. Oh, I'm way at the bottom, aren't I?
Yeah.
Colon, rectum, anus, bottom. You'll never forget that. Your whole idea of just cancer pathology has just really gone down the toilet. And I could keep going with these analogies if I wanted to, but then again, there you go. So there's several in here. So if you would, they're towards the end, and I build in the cases, and I try to be a little, well, you would never imagine, kind of funny, but what the researcher's intending, right, and or the clinician. And so I spell the cases out sequentially with additional refinements, as of course we have to do with our non-terminology friends. So I think how many cases do we go down through, or iterations? At least. And if you have any questions, my email's around. It's fun to, if anybody dares talk, emails about this, is like, oh, there's another weird person in the world. It's really nice to know one. And we can, we can ECL together. So exciting, I'm telling you. And then we can try to organize the rest of the world, and all will be well. Does anybody have any questions on this? We are writing implementation guides on this because this is a new application for the hard work that Daniel and the observations group did. We wanted to do something though and really test it, and with a very specific use case, and which cancer synoptic reporting is. So, and I am not going to get in the way of drinks.
Scroll down. We got a question?
It was just around ECL queries and, like time frames. So I just wondering, did you do much in real life use cases where you look at maybe time frames from cancer pathology, like sample into diagnosis?
Yes, with the date of the specimen, for example. So I wanted to say, is that what you're talking about? Like actual temporal experience?
Yeah.
Yeah, so that would be a component of that actually would be a component of the information model. So when the laboratory report is coming over from our system, there would be this is the date of the study, right? Or the day of the exam. And so, yeah, that we could do that. And in fact, Jim and I did a big study that, I never have enough time to write up, where we use these types of data to say, I want to know all the colorectal cancer cases that we have found at the University of Nebraska, starting in 2006 through 2020, and went metastatic during that process, and had a genetic study, whether it's by immunohistochemistry or whole genome sequencing or anything in between, and got targeted genetic therapy. And we did this is our data good enough, right? And now we had to cobble some sources together, but a computable sense. And we did a blinded full chart review at the same time. And we were able to do that successfully. I think we had one mistake. One person was noted as computationally as receiving a targeted therapy, but by chart review was not, because the drug was dispensed from the dispensary, brought bedside, and the patient was no longer healthy to take the drug. So that was I'll take that miss computationally at this stage of the game. Does that help? Because then we had to do all of these temporally. And when was the test? When were you born? Did you die? Did the patient, expire through that period? So very much. You bet.
Scott, would you scroll down in the document to the last page?
Yes.
No, the Word document.
Oh, I'm sorry.
I apologize that we don't have time to, get into all the details on this, but I included one use case at the end that basically integrates data across multiple systems or multiple types of SNOMED data. And this is basically in the design of an antibiogram, which is basically a decision support technology that takes the results of the microbiology lab test on the bacteria, okay, identifies which drugs can be used to treat the patient, and then selects drugs from the formulary for the clinician to choose. Those are drugs that are going to work, and we've got here at our institution. And this is a computer. This is an example that shows that it really is important that you manage all of your data, and that we can do queries that pull out this level of detail and what was actually accomplished by our clinicians. So I've got several slides on that, and as I say, the ECLs there show you how to query into the observables and the medication model and so forth in order to do that.
There you go. Any questions for anything? I think we have 5 minutes before drinks, and so you'd be early, you'd be first in line, or you can.
I think it's fair to say as well that, like as Scott said, well, most of us, pretty much all of us, are really love this stuff and are pretty geeky about it. So we're very, very happy if anybody either online or as well or here wants to go into any more detail. I feel like it's just we've just touched the surface of,
Yeah, I mean, it would be like a
this.
story I can tell my wife. Somebody called me up
So
today.
please
And I
do get in touch.
realize I didn't include our emails or anything in the slide.
Oh,
Do I have your collective permissions? I'll reissue the slides with our emails.
Absolutely, and I think it might be in the app.
oh yeah. How will participants access the documents, both the ECL queries and the other materials?
Apparently, the ECL queries were not set up on the handouts by SNOMED. I'll make sure that they're there. So you should be able to get them by a link from the conference site. Yeah.
And I think our presenter details, if we've all clicked the right buttons, are available in the app and the thing. So please do contact us.
Wonderful. Thank you, everybody, for coming. You sat for 4 hours. You guys are either gluttons for punishment or not that smart or bored. Thank you so much for coming.
Oh, and actually, just one final comment. I know that thank you to all of my colleagues and friends who have done this, but particularly thank you to Jim for corralling us all into doing this again, and I mean particularly corralling us as well, because we get distracted and we wander off easily, and so Jim kept us in line and kept us doing this. So special thank you to Jim.